Welcome, friends. I'm so glad you're here. Whether you're drifting towards sleep, unwinding after a long day, or simply looking for a quiet companion, you found the right place. Before we begin, I'd love to know, where in the world are you listening from? Perhaps you're wrapped in a blanket, sitting by a softly lit window, or resting somewhere under an open sky. Wherever you are, I hope you're warm, comfortable, and ready to wander with me into the hidden worlds that might exist right alongside our own Earth. If you find peace or curiosity in these gentle stories, please consider liking the video, subscribing to the channel, or sharing it with someone who might need a moment of stillness too. And to those who've already joined along, thank you. The universe holds more empty space than substance, a fact so profound it reshapes how we understand the very nature of existence. Between the nucleus of an atom and its orbiting electrons stretches a void so vast that if an atom was scaled to the size of a cathedral, its nucleus would be smaller than a coin resting on the altar, while its electrons would orbit like distant birds circling the spires. This fundamental truth whispers of hidden rooms within reality itself, spaces where entire worlds might nestle unseen between the familiar particles of our daily existence. Within this cosmic architecture of emptiness, scientists have discovered that ordinary matter, the stuff of stars, planets, human bodies, and everything we can touch or see, comprises less than 5% of everything that actually exists. The remaining 95% flows through a universe populated by dark matter and dark energy, substances that bend space-time and accelerate the expansion of the cosmos while remaining completely invisible to our most sophisticated instruments. Only their gravitational fingerprints reveal their presence, like footsteps in cosmic snow leading toward unseen companions who have walked this way before us. The mathematics of this hidden majority grows more mysterious with each calculation. Dark matter outweighs visible matter by a ratio of nearly 6-to-1, forming an invisible scaffolding around which galaxies arrange themselves like ornaments on a Christmas tree we cannot see. This phantom architecture could easily harbor entire shadow galaxies, complete with their own stars, planets, and perhaps even forms of life constructed from particles that pass through our bodies billions of times each second without our awareness. The possibility feels less like science fiction and more like inevitable consequence of laws we are only beginning to understand. Modern telescopes have discovered over 5,000 planets orbiting distant stars, and statistical models suggest our galaxy alone harbors billions more, perhaps as many as 400 billion worlds scattered across the Milky Way's spiral arms like seeds on cosmic wind. Some of these worlds circle their suns at precisely the right distance for liquid water to pool on their surfaces, neither too close for the seas to boil away, nor too distant for them to freeze into permanent ice. A few possess rocky compositions nearly identical to Earth's delicate blend of silicon, iron, and lighter elements. Several maintain atmospheres thick enough to trap warmth beneath protective blankets of gas while remaining thin enough to allow starlight to reach their surfaces. The mathematics of probability insists that among these multitudes, perfect twins of our pale blue dot must exist, worlds where familiar seas might lap against shores built from the same elements that form our own continents, where mountains rise towards skies colored by the same physics that paint our sunsets, where perhaps even life has emerged from the same patient chemistry that gave rise to the first cells in Earth's ancient oceans. The universe appears to favor repetition over uniqueness, creating countless variations on successful themes across the cosmic expanse. Quantum mechanics adds another layer of mystery to this cosmic hide-and-seek game that spans both the infinitely small and the incomprehensibly vast. Every subatomic interaction branches reality into multiple possible outcomes, each path as real and valid as the one we happen to experience. These parallel quantum states suggest that alternate versions of Earth exist where different choices were made at the molecular level. where evolution took different turns, where the asteroid that ended the dinosaurs missed its target by mere miles, where perhaps you are listening to different words under different stars, in a universe where the speed of light follows slightly different rules. The mathematics works out so elegantly that many physicists now consider parallel universes not wild speculation, but inevitable consequence of the quantum mechanical laws that govern reality at its smallest scales. Each measurement, each quantum event, each collision between particles splits the universe like a river delta branching toward infinite seas. In some of these parallel streams, Earth never formed. In others, it formed twice. In still others, it formed perfectly, but in locations we would never think to look. Nestled in dimensions our senses cannot perceive or tucked into the spaces between the spaces we think we understand. Yet for all our sophisticated instruments and elegant equations, the fundamental question remains tantalizingly simple. Could another Earth be hiding right next to us? Perhaps in dimensions folded so tightly that entire universes fit into spaces smaller than the period at the end of this sentence. Perhaps in quantum states our minds cannot imagine, where probability waves collapse differently and create worlds where the same physics produce different outcomes. Perhaps embedded in the dark matter scaffolding that surrounds our solar system like an invisible web, supporting structures we cannot see but whose effects we measure every day. The universe has kept such secrets before, revealing them only when our instruments grew sensitive enough, and our mathematics grew sophisticated enough to detect patterns hiding in plain sight. Only recently did we realize that space itself expands like a balloon being inflated by invisible hands. That time dilates near massive objects as if it were made of something pliable rather than absolute. That particles can exist in multiple locations simultaneously until observed, at which point they choose a single reality from among infinite possibilities. What other revelations wait in the shadows between what we see and what truly exists? The cosmos operates on principles both stranger and more subtle than early astronomers dared imagine when they pictured celestial spheres rotating in perfect circles around a stationary Earth, where they saw clockwork precision. We now map curved space-time threaded with wormholes and populated by objects so dense they tear holes in reality itself, creating regions where cause and effect become negotiable, and where the normal rules of existence bend until they break. The possibility of hidden Earths feels almost conservative by comparison, merely another reminder that the universe prefers mystery to simplicity, depth to surface appearances, quiet complexity to obvious truths. Each night, as familiar stars wheel overhead in their ancient patterns, remember that each point of light might illuminate worlds where other seas reflect other moons, where other mountains catch the light of other dawns, where other beings might look up at their own night sky and wonder if they are alone. The mathematics says such worlds must exist. The physics says they could be anywhere. The mystery says they might be closer than we ever imagined, waiting patiently in the spaces between atoms, in the folds of space-time, in the parallel paths where probability becomes reality and reality becomes infinite. Spinning quietly in the dark between the stars, we can see and the countless others that remain hidden in the universe's vast and patient shadows. The pale blue dot that carries all of human history through space may not be as unique as our ancestors imagined when they gazed upward at night skies unpolluted by electric light. In the constellation Cygnus, approximately 1,400 light-years from Earth, a planet designated Kepler 452b orbits its sun at almost exactly the same distance that Earth orbits ours, completing its year in 485 days, just 20% longer than our own orbital dance around the sun. This world receives only 10% more energy from its star than Earth receives from ours, a difference so slight that if this distant world possesses an atmosphere even marginally thicker than our own, Its surface temperatures might fall within the narrow range where water remains liquid across vast continental seas that could mirror our Pacific and Atlantic in their patient circulation patterns. Its star burns with the same steady yellow light that warms our mornings and illuminates our evenings. A stellar twin so similar to our Sun that astronomers initially struggled to distinguish between their spectral signatures when analyzing the light through powerful telescopes. The planet itself appears to be 60% larger than Earth, suggesting a rocky composition beneath whatever clouds might shroud its surface from the gaze of distant instruments. If gravity follows the same laws there as here, beings on that world would weigh roughly twice what they weigh on Earth, a subtle difference that would reshape the evolution of life without preventing its emergence entirely, perhaps creating creatures with stronger bones and more powerful hearts adapted to the increased pull toward their world's center. The discovery of Kepler 452b represents just one note in a growing symphony of potentially habitable worlds scattered throughout our cosmic neighborhood, like seeds cast by an invisible gardener across the fertile darkness between stars. The Kepler Space Telescope, during its primary mission from 2009 to 2013, stared at a single patch of sky containing roughly 150,000 stars for over 4 years, watching with mechanical patience for the telltale dimming that occurs when a planet passes between its star and Earth. This transit method, requiring precision measurements of starlight variations as small as 1 part in 10,000, revealed that rocky planets orbiting within their stars' habitable zones are not rare cosmic accidents, but common architectural features of planetary systems throughout the galaxy. Statistical analysis of Kepler's data suggests that roughly 1 in 5 Sun-like stars hosts an Earth-sized planet within the temperate zone where liquid water can exist on a world's surface without boiling into vapor or freezing into permanent ice. Our galaxy contains perhaps 200 billion stars, meaning that 40 billion potentially habitable worlds might circle through space within the Milky Way alone, each one spinning through days and nights that could feel familiar to travelers from Earth. The mathematics grows more staggering when extended to the observable universe, which contains at least 2 trillion galaxies, each populated by hundreds of billions of stars, many accompanied by planetary families that mirror our own solar system's basic architecture of small rocky worlds near their stars and larger gas giants farther out. Among these multitudes, some worlds must possess not merely the potential for habitability, but the precise combination of factors that make them virtually indistinguishable from Earth in every measurable parameter. Consider TRAPPIST-1, a small red dwarf star 39 light-years distant, surrounded by 7 rocky planets packed more tightly than the distance between Mercury and the Sun, yet arranged with such precision that 3 of these worlds orbit within the narrow zone, where surface temperatures allow liquid water to persist across continental land masses. At least 2 of these planets appear to be nearly identical to Earth in both size and density, suggesting similar compositions of iron, silicon, and the lighter elements that form the rocky foundations of terrestrial worlds. The system's compact arrangement means that these planets would appear as bright crescents in each other's skies, visible to the naked eye like multiple moons sharing the same celestial dome. From the surface of TRAPPIST-1e, the most Earth-like of the 7 worlds, the neighboring planets would appear several times larger than our moon appears in Earth's sky, close enough that their surface features might be discernible without telescopes, creating night skies populated by other worlds instead of distant points of light. The gravitational interactions between these tightly packed planets create complex tidal forces that could drive geological activity, maintaining the volcanic processes that keep planetary atmospheres replenished with gases essential for life. The irony of cosmic abundance becomes apparent when we consider that each of these worlds experiences its own version of what we consider uniquely terrestrial phenomena. Somewhere among the 40 billion potentially habitable planets in our galaxy, rain might fall on continents arranged in patterns that echo Earth's familiar continental drift, with mountain ranges rising along collision zones where tectonic plates meet and ocean basins opening where they pull apart. Somewhere else, seasons change as worlds tilt on axes similar to our own, creating cycles of warmth and cold that drive atmospheric circulation patterns nearly identical to the jet streams and trade winds that shape our climate and distribute heat from equatorial regions toward polar ice caps. The same physics that creates Earth's aurora might paint alien skies with curtains of green and purple light as solar particles interact with magnetic fields generated by molten iron cores spinning beneath foreign ground, creating compass needles that point toward magnetic poles on worlds where other beings might navigate by stars arranged in different constellations. Ocean currents driven by temperature differences and planetary rotation could carve familiar patterns of circulation in alien seas, creating Gulf Streams that warm distant shores and upwelling zones that bring nutrients to the surface, supporting food webs built from the same basic chemistry that sustains life in Earth's oceans. Yet for all this statistical certainty about Earth-like worlds, the actual detection and characterization of these planetary siblings remains tantalizingly difficult. Like trying to photograph fireflies dancing around searchlights from thousands of miles away, the transit method that revealed their existence provides only indirect evidence, subtle changes in starlight that must be measured to precisions of parts per million over periods of years, requiring space telescopes to monitor the same stars continuously without interruption. Most potentially habitable planets will never transit their stars from Earth's perspective, remaining forever hidden unless future technologies develop the capability to block out the overwhelming glare of distant suns and photograph their planetary families directly. The James Webb Space Telescope has begun to analyze the atmospheres of a few nearby exoplanets, detecting water vapor, carbon dioxide, methane, and other familiar molecules in the air of worlds dozens of light years away. These spectroscopic fingerprints provide the first concrete evidence that Earth-like chemistry operates on distant worlds. But the technique works only for planets that transit particularly bright stars under nearly perfect observing conditions. The telescope must capture starlight filtered through planetary atmospheres during the brief moments when worlds pass between their stars and Earth, analyzing how different wavelengths of light are absorbed by atmospheric gases to create chemical signatures as distinctive as fingerprints. Thousands of potentially identical Earths remain invisible to current instruments, hidden by the brilliant light of their parent stars or orbiting at angles that never bring them between their suns and our telescopes. These hidden worlds might possess continents and oceans, seasons and weather patterns, perhaps even forms of life that evolved along pathways parallel to Earth's biological history. The universe's preference for repetition over uniqueness suggests that the precise conditions that allowed life to emerge in Earth's ancient oceans have been replicated countless times across cosmic history, creating worlds where similar chemistry gave rise to similar complexity. Perhaps most intriguing are the rogue planets, worlds ejected from their birth systems by gravitational interactions with larger planets or passing stars, now wandering through interstellar space without any star to warm their surfaces with steady light. Recent surveys using gravitational microlensing, a technique that detects planets by their gravitational effect on background starlight, suggest these cosmic orphans might outnumber stars themselves, drifting through the galaxy's spiral arms like invisible islands, carrying whatever atmospheres and internal heat they retained from their formation billions of years ago when they condensed from the same stellar nurseries that gave birth to our own solar system. Some of these wandering worlds might be Earth-sized, maintaining liquid subsurface oceans heated by radioactive decay in their cores and tidal forces from captured moons, supporting ecosystems that evolved in eternal darkness beneath kilometers of ice. These hidden biospheres would remain completely isolated from the rest of the universe, developing forms of life adapted to conditions of perpetual winter and internal heat, creating alien evolution experiments that might produce results as strange as anything we could imagine, yet as real as the familiar life forms that populate Earth's own hidden depths. The possibility that exact Earth twins exist becomes more probable with each new discovery of exoplanetary diversity and the growing catalogue of worlds that challenge our assumptions about planetary formation and evolution. Among the thousands of confirmed worlds orbiting distant stars, we have found planets made of diamond with surfaces that sparkle like cosmic jewelry, worlds where it rains molten glass sideways in supersonic winds that reshape continents daily, gas giants so close to their stars that their atmospheres stream away into space like comet tails, creating planetary systems that operate according to the same physical laws as our own, while producing results that stretch the boundaries of what we considered possible. This exotic menagerie suggests that planetary formation operates like a cosmic laboratory, experimenting with every possible combination of size, composition, orbital distance, and stellar environment across billions of years of cosmic time, somewhere in this vast experimental space. The precise conditions that produced Earth must have been repeated many times, creating worlds where familiar blue oceans reflect familiar white clouds beneath skies that would look like home to travelers from our own small planet spinning through the darkness between stars that burn with light identical to our sun's patient radiance, warming the morning air that carries the scent of growing things toward windows where other beings might pause to wonder about the possibility of other worlds hidden among the countless points of light scattered across night skies that stretch beyond the reach of any imagination. Gravitational whispers drift through the cosmos like voices from an invisible choir, revealing the presence of matter that refuses to interact with light, yet shapes the architecture of everything we can see. Dark matter comprises roughly 27% of the universe's total mass energy budget, outweighing all visible stars, planets, and gas clouds by a ratio of more than 5-1. This phantom substance forms an invisible scaffolding around which galaxies arrange themselves like ornaments on a Christmas tree we cannot perceive, creating structure on scales so vast that our entire local group of galaxies appears to be embedded within a single dark matter halo stretching across millions of light years. The evidence for dark matter's existence emerges from countless astronomical observations that refuse to match the predictions of gravity acting on visible matter alone. Spiral galaxies rotate too quickly for their outer stars to remain gravitationally bound. Yet these stellar systems maintain their elegant pinwheel shapes across billions of years without flying apart into cosmic debris. Galaxy clusters move through space as coherent units despite containing individual galaxies traveling at speeds that should scatter them across the universe like marbles rolling off a tilted table. The cosmic microwave background radiation carries subtle temperature variations that can only be explained by the gravitational influence of matter that interacts with ordinary particles through gravity alone. Modern computer simulations of cosmic evolution require dark matter to reproduce the large-scale structure we observe today, the cosmic web of galactic filaments separated by vast voids that stretches across billions of light years, like the neural networks of some inconceivably vast mind. Without dark matter's invisible influence, these simulations produce universes where galaxies never form at all, leaving only diffuse clouds of hydrogen and helium drifting through empty space. The fact that we exist within complex galactic ecosystems populated by heavy elements forged in stellar cores provides indirect proof that dark matter shapes cosmic evolution in ways we are only beginning to understand. Yet the mystery deepens when physicists attempt to identify what dark matter actually consists of at the particle level. Laboratory experiments designed to detect dark matter particles directly have produced decades of null results despite increasingly sensitive detector arrays buried deep underground to shield them from cosmic ray interference. The Large Hadron Collider has failed to create any of the hypothetical particles that theoretical models predict should constitute dark matter. leaving physicists to wonder whether their fundamental assumptions about particle physics require revision or whether dark matter operates according to principles more exotic than current theories can accommodate. Some theoretical frameworks suggest that dark matter might not consist of particles at all, but rather represent evidence for modifications to gravity itself on cosmic scales. Alternative theories propose that what we interpret as dark matter's gravitational influence actually reflects the presence of extra-spatial dimensions folded so tightly that they remain invisible while still affecting the motion of ordinary matter through gravitational interactions that leak between dimensional boundaries. These ideas push the boundaries of physics into realms where space and time become malleable concepts rather than fixed stages upon which cosmic drama unfolds. The possibility that dark matter forms its own complex ecosystem hidden alongside our familiar universe grows more intriguing with each failed attempt to detect it through conventional means. If dark matter particles interact with each other through forces analogous to electromagnetism or nuclear interactions, but completely separate from the forces that govern ordinary matter, entire shadow galaxies could exist within the same regions of space occupied by visible galaxies. These dark structures might contain their own equivalent of stars, planets, and perhaps even forms of organization complex enough to be considered alive, all completely invisible to instruments designed to detect electromagnetic radiation. Recent observations of galaxy cluster collisions provide tantalizing hints that dark matter might indeed exhibit internal structure more complex than simple gravitational attraction. When the Bullet cluster, comprising two galaxy clusters that pass through each other at speeds of several thousand kilometers per second, was mapped using gravitational lensing techniques, the dark matter appeared to separate cleanly from the ordinary matter during the collision. This behavior suggests that dark matter particles interact with each other only weakly, if at all, allowing dark matter structures to pass through each other like cosmic ghosts, while ordinary matter gets heated and disrupted by electromagnetic forces during the collision process. The implications for hidden cosmic civilizations become profound when we consider that dark matter's gravitational influence could support planetary systems completely invisible to optical astronomy. Dark matter stars powered by the annihilation of dark matter particles rather than nuclear fusion could provide stable energy sources for billions of years, supporting dark matter planets where evolution might proceed along pathways entirely separate from biological processes based on carbon chemistry. These shadow ecosystems would remain forever inaccessible to exploration using conventional spacecraft, but might exist in the same regions of space where Earth orbits the Sun, occupying parallel gravitational relationships that mirror the architecture of our own solar system. The search for dark matter continues through increasingly sophisticated experiments that attempt to detect the theoretical particles through their rare interactions with ordinary atomic nuclei. Deep underground laboratories house arrays of ultra-pure crystals cooled to temperatures approaching absolute zero, waiting for the telltale energy deposits that would signal dark matter particles streaming through Earth like cosmic rain. Particle accelerators search for signatures of dark matter production in high-energy collisions, while space-based gamma-ray telescopes scan for the distinctive radiation patterns that might result from dark matter particle annihilation in the dense cores of galaxies. Yet perhaps the most profound mystery lies not in dark matter's particle nature, but in its potential for complexity and organization on scales we have not yet learned to observe. If dark matter forms structures analogous to atoms and molecules, entire periodic tables of dark elements might exist, supporting dark chemistry that operates according to principles parallel to but separate from the chemical processes that drive life on Earth. Dark matter planets might harbor dark matter life forms that evolve, reproduce, and build civilizations using technologies based on forces that remain completely invisible to our instruments while sharing the same cosmic neighborhood where humans have learned to wonder about their place in a universe far stranger than their ancestors ever imagined. The universe's preference for hidden complexity over obvious simplicity suggests that dark matter represents only the beginning of cosmic mysteries waiting to be unraveled by future generations of scientists equipped with instruments sensitive enough to detect the subtle influences of matter that interacts with our familiar world only through the patient pull of gravity across distances measured in light years. Each gravitational whisper from the cosmic dark carries information about structures and processes that operate just beyond the threshold of current detection, reminding us that the universe contains depths of reality that dwarf our current understanding, like ocean trenches that stretch deeper than mountains reach toward the sky. Populated by forms of existence as alien to our experience as the pressure and darkness of the deepest abyssal plains, yet as real as the morning light that illuminates the familiar world where we have learned to listen for voices calling from the spaces between the stars. The mathematics of infinity suggests that if space extends beyond the observable universe's cosmic horizon, then every possible arrangement of matter and energy must occur not just once, but infinitely many times across distances so vast they exceed human comprehension. This principle, known as the cosmological principle of infinite repetition, emerges naturally from quantum mechanics and cosmic inflation theory, two of modern physics' most successful theoretical frameworks. If the universe is truly infinite in spatial extent, then the finite number of ways that matter can be arranged within any given volume guarantees that identical copies of Earth exist at regular intervals throughout space, separated by distances containing roughly 10 to the power of 10 to the power of 29 meters between each perfect duplicate. Cosmic inflation theory, proposed to explain the remarkable uniformity of the cosmic microwave background radiation, suggests that our observable universe represents only an infinitesimally small bubble within a vast multiverse, where space continues to expand exponentially in regions beyond our cosmic horizon. This inflationary process creates pocket universes like soap bubbles forming in an infinite bath of expanding space-time, each bubble containing its own version of physical laws, fundamental constants, and initial conditions that determine how matter organizes itself into galaxies, stars, and planetary systems across billions of years of cosmic evolution. The eternal inflation model, developed by physicists like Alan Guth and Andre Linde, proposes that this process never ends but continues indefinitely, creating an infinite number of universe bubbles separated by regions of space that expand faster than light can travel between them. Within this framework, every possible combination of physical laws and initial conditions gets realized somewhere in the multiverse, meaning that universes exist where gravity operates differently, where electromagnetic forces follow altered rules, where the speed of light takes on different values, and where the fundamental particles that constitute matter exhibit properties that would seem exotic compared to our familiar physics. Quantum mechanics adds another layer of multiplicity through the many worlds interpretation, which suggests that every quantum measurement splits reality into parallel branches where each possible outcome occurs in a separate universe. Since quantum events happen trillions of times per second in every cubic centimeter of space, the branching process creates an astronomical number of parallel realities diverging from our own timeline at every moment. Some of these branches differ only in the position of a single electron, while others diverge dramatically based on quantum fluctuations that affect macroscopic events like genetic mutations, weather patterns, or the precise trajectories of asteroids through planetary systems. The anthropic principle provides a framework for understanding why we observe a universe with physical constants precisely tuned to allow the formation of complex structures like stars, planets, and living organisms. In a multiverse containing every possible combination of physical laws, conscious observers can only exist in universes where the constants fall within narrow ranges that permit stable atomic nuclei, long-lived stars, and chemical complexity. This selection effect means that we inevitably find ourselves in a universe that appears designed for life, not because it was intentionally created that way, but because universes with different physical laws either collapse too quickly or remain too simple to support the emergence of beings capable of asking questions about their cosmic environment. String theory, which attempts to unify quantum mechanics with general relativity, suggests that our familiar three dimensions of space plus one dimension of time represent only a subset of reality's true geometric structure. The mathematics of string theory requires at least 10 or 11 total dimensions to remain mathematically consistent, with the extra dimensions either compactified into spaces too small to detect or extending into regions of space-time that remain inaccessible to particles and forces operating in our familiar four-dimensional universe. Different ways of compactifying these extra dimensions produce different effective physics in the resulting four-dimensional space, creating a vast landscape of possible universes with varying fundamental constants and particle properties. Current estimates suggest that string theory allows for roughly 10 to the power of 500 different ways to arrange the extra dimensions, each producing a universe with its own unique physics. This string landscape provides a natural mechanism for generating the multiverse required by anthropic reasoning, with different regions of space corresponding to different points in the landscape where extra dimensions take on different configurations. Transitions between these regions could occur through quantum tunneling processes or cosmic inflation events that reshape the geometric structure of space-time itself. The implications for parallel Earths become staggering when we consider that each universe in this multiverse could contain its own version of cosmic evolution, stellar formation, and planetary development. In universes where gravity operates slightly differently, solar systems might form with different orbital architectures, creating worlds where Earth-sized planets orbit at distances that produce climates ranging from permanent ice ages to runaway greenhouse effects. In universes where electromagnetic forces follow altered rules, the chemistry of life might proceed along entirely different pathways, producing biospheres based on exotic elements or energy sources that remain impossible in our familiar physics, even within universes that share our fundamental physical laws. The quantum branching process ensures that infinite variations of Earth exist where history unfolded differently due to quantum fluctuations that affected crucial events. Some of these parallel Earths experienced asteroid impacts at different times or locations, producing mass extinctions that eliminated different species and allowed alternative evolutionary pathways to dominate. Others underwent continental drift patterns that arranged land masses in configurations that promoted different climate patterns, ocean circulation systems, and biogeographic distributions of life forms. The mathematical precision required for conscious observers to emerge and contemplate their cosmic situation suggests that we occupy an incredibly rare and precious corner of the multiverse, where physical laws permit not only the formation of complex structures, but also the development of intelligence capable of discovering these same physical laws through scientific investigation. The fact that we can understand quantum mechanics, general relativity, and cosmic inflation well enough to predict the existence of parallel universes represents a kind of cosmic self-awareness, where the universe develops the capacity to understand its own fundamental nature through the emergence of conscious beings who can decode the mathematical principles that govern reality at its deepest levels. Yet the multiverse hypothesis remains fundamentally untestable using conventional scientific methods, since by definition we cannot observe or communicate with parallel universes that exist beyond our cosmic horizon or in different quantum branches of reality. This limitation has led some physicists to question whether multiverse theories constitute legitimate science or merely elegant mathematical speculation that cannot be distinguished from philosophy. The debate continues among cosmologists who must balance the theoretical elegance of multiverse models against the scientific principle that theories should make testable predictions about observable phenomena. Nevertheless, the mathematical consistency of quantum mechanics and general relativity appears to require some version of the multiverse, whether through eternal inflation, quantum branching, or the string theory landscape. The alternative explanations for cosmic fine-tuning either invoke supernatural intervention or require abandoning successful physical theories that have been verified through countless experiments and observations. The multiverse emerges not as wild speculation, but as an inevitable consequence of taking our best physical theories seriously and following their mathematical implications to their logical conclusions. In the vast spaces between universes, where different physics creates different possibilities for matter and energy to organize themselves into complex systems. The mathematical certainty of infinite repetition ensures that every possible Earth exists somewhere in the multiverse's infinite expanse. Some of these worlds harbor civilizations that have discovered the same mathematical principles we use to deduce their existence, creating a kind of transdimensional resonance where conscious beings separated by impossible distances share the profound realization that they exist within a cosmos far stranger and more magnificent than any single universe could contain. Connected across the infinite spaces of the multiverse by the patient mathematics that describes how reality organizes itself into patterns complex enough to contemplate their own existence under alien stars that shine with familiar light. Proxima Centauri, the closest star to our solar system, burns with a patient red glow just 4.2 light-years from Earth, close enough that radio signals traveling at light speed would take only 4 years and 77 days to bridge the gap between our worlds. This small red dwarf star, barely 1/8 the mass of our Sun, harbors at least 2 confirmed planets in its gravitational embrace, including one rocky world designated Proxima Centauri b that orbits within the narrow zone where liquid water might pool on its surface beneath whatever atmosphere shields it from the harsh radiation environment that characterizes most red dwarf planetary systems. Proxima b completes its orbit around its dim red star in just 11.2 Earth days, circling so close to its parent star that the same hemisphere always faces toward the light, while the opposite side remains locked in perpetual darkness. This tidally locked configuration creates extreme temperature gradients between the day and night sides, with computer models suggesting that the sunlit hemisphere might reach temperatures hot enough to vaporize water, while the dark side freezes into landscapes of nitrogen and carbon dioxide ice. Yet atmospheric circulation could potentially transport heat from the hot side to the cold side, creating a twilight zone around the planet's terminator where temperatures might remain moderate enough for liquid water to persist in sheltered valleys or crater basins. The planet receives approximately 1.4 times more stellar energy per unit area than Earth receives from the Sun, but Proxima Centauri emits most of its energy in infrared wavelengths rather than the visible light that drives photosynthesis on Earth. This difference in stellar spectrum could fundamentally alter how life might emerge and evolve on Proxima b, potentially favoring organisms adapted to harvest energy from longer wavelengths of electromagnetic radiation or developing biochemistry based on chemical energy sources rather than photosynthesis. The planet's mass appears to be at least 1.3 times Earth's mass, suggesting similar surface gravity that would feel familiar to travelers from our own world. Recent observations using high-precision radial velocity measurements have revealed hints of a second planet, Proxima c orbiting much farther from the star with a period of roughly 5.2 years. This outer world appears to be several times more massive than Earth, possibly a super-Earth or mini-Neptune with a thick atmosphere that could trap heat from the star's faint radiation. The existence of multiple planets in the Proxima Centauri system suggests a complex, dynamical history where gravitational interactions between worlds shaped their final orbital configurations, potentially creating conditions for long-term climate stability on the inner planet despite its close proximity to a variable red dwarf star. Red dwarf stars like Proxima Centauri present both advantages and challenges for planetary habitability compared to Sun-like stars. Their extremely long lifespans, measured in trillions of years rather than the 10 billion year lifespan expected for our Sun, provide vast amounts of time for life to emerge, evolve, and develop complexity on any planets that maintain stable surface conditions. However, red dwarfs also produce powerful stellar flares that can strip away planetary atmospheres over geological timescales, creating environments where only worlds with strong magnetic fields or unusually thick atmospheres might retain the surface conditions necessary for liquid water and complex chemistry. The Proxima Centauri system has become the primary target for humanity's first serious attempts at interstellar exploration, with the Breakthrough Starshot initiative proposing to send tiny spacecraft propelled by powerful laser arrays toward the system at speeds approaching 20% of light speed. These miniaturized probes, each weighing only a few grams and equipped with gossamer light sails, could potentially reach Proxima Centauri within 20 to 30 years of launch, transmitting the first close-up images and data from another star system back to Earth across the 4-light-year gap that separates our cosmic neighborhoods. The European Southern Observatory's Very Large Telescope has detected possible signs of water vapor in Proxima B's atmosphere using spectroscopic techniques that analyze how starlight changes as it passes through the planet's atmosphere during rare transit events. These preliminary observations suggest that the planet might indeed possess substantial atmospheric mass, potentially including water molecules that could condense into clouds or precipitation under the right temperature and pressure conditions. However, the measurements remain at the limits of current instrumental precision, leaving open the possibility that what appears to be water vapor might actually represent other atmospheric constituents that produce similar spectroscopic signatures. Direct imaging of Proxima b remains beyond the capabilities of current telescopes due to the overwhelming brightness difference between the planet and its host star. Despite Proxima Centauri being among the faintest known stars, the planet appears roughly 10 million times dimmer than its star when observed in visible light, requiring coronagraph instruments capable of blocking starlight with unprecedented precision to reveal the faint reflected light from the planet's day side. Future space telescopes designed specifically for exoplanet characterization might eventually obtain direct images that reveal whether Proxima b possesses continents, oceans, clouds, or other surface features that would indicate active geological or atmospheric processes. The possibility that life might already exist on Proxima b has inspired numerous theoretical studies of how evolution might proceed under the exotic conditions that characterize red dwarf planetary systems. Organisms adapted to the planet's tidally locked nature might migrate seasonally between different climate zones as atmospheric circulation patterns shift with long-term changes in stellar output. Life forms evolving under predominantly infrared radiation might develop biochemical pathways that remain completely unknown on Earth, potentially producing ecosystems whose basic metabolic processes operate according to principles that terrestrial biology has never explored. The system's proximity to Earth has also made it a prime target for searches for artificial radio signals or other technological signatures that might indicate the presence of intelligent life. The search for extraterrestrial intelligence has conducted numerous observations of Proxima Centauri using radio telescopes around the world, listening for narrowband signals or other patterns that would be difficult to explain through natural astrophysical processes. So far, these searches have detected only the background hiss of cosmic radio waves and the occasional burst of stellar radio emission from Proxima Centauri's magnetic field interactions with solar wind particles. Yet the absence of detectable signals from Proxima b tells us nothing definitive about whether life exists there, since any civilization that might have emerged in the system could be using communication technologies that remain invisible to our current detection methods, or might exist at a level of technological development where they have not yet discovered radio wave propagation or choose not to broadcast powerful signals into space. The universe of possible alien technologies extends far beyond the electromagnetic spectrum that defines human communication, potentially including quantum entanglement networks, gravitational wave modulation, or exotic forms of information transfer that operate according to physical principles we have not yet discovered. The gravitational dynamics of the Proxima Centauri system create additional possibilities for hidden worlds that might have escaped detection by current planet hunting techniques. Small rocky planets orbiting in resonant relationships with Proxima b could remain invisible to radial velocity surveys if their gravitational effects on the star partially cancel each other out, while rogue planets ejected from the system during its early formation might wander through the outer regions of interstellar space, carrying subsurface oceans heated by radioactive decay or tidal forces from distant gravitational interactions. Perhaps most intriguingly, the system's membership in the Alpha Centauri triple star system creates a complex gravitational environment where planets might be exchanged between stellar components over millions of years, potentially transporting worlds that formed around one star into orbits around different stars with varying radiation environments. This gravitational choreography could create scenarios where planets experience dramatic climate changes as they migrate between different stellar hosts, driving evolutionary pressures that favor organisms capable of adapting to rapidly changing environmental conditions or entering dormant states that allow them to survive extended periods of unfavorable climate. The red dwarf's dim but steady light has been shining across the 4-light-year gap for billions of years, carrying with it the possibility that another world orbits in the gentle warmth of an alien sun while beings adapted to perpetual twilight might pause in their daily activities to wonder whether distant points of light in their night sky harbor other forms of consciousness, contemplating the possibility of life among the stars. The mathematics of orbital mechanics and stellar evolution suggests that if life emerged in the Proxima Centauri system, it has had far longer to develop complexity than life on Earth, potentially creating civilizations whose technologies and perspectives on the universe evolved across timescales that dwarf the brief span of human history under the patient light of stars that will continue burning long after our own sun has exhausted its nuclear fuel and faded into the cosmic dark that stretches between islands of light separated by distances that measure the true scale of space and time in a universe where neighbors exist just beyond the reach of current exploration, but well within the boundaries of future discovery. Between the folds of space-time lie dimensions so small that billions of complete universes could exist within the space occupied by a single proton. Yet these hidden realms might harbor worlds as complex and varied as any we could imagine in the familiar 3 dimensions of length, width, and height that define our everyday experience. Modern physics suggests that reality possesses at least 6 additional spatial dimensions beyond the 3 we perceive, all compactified into geometric structures so tiny that they remain invisible to our instruments while still influencing the fundamental forces that govern particle interactions and determine the constants of nature that make chemistry and biology possible. String theory. Humanity's most ambitious attempt to unify quantum mechanics with general relativity requires these extra dimensions to resolve mathematical inconsistencies that arise when physicists attempt to describe gravity using the same quantum mechanical principles that successfully explain electromagnetic, weak nuclear, and strong nuclear forces. The mathematics works only when vibrating strings of energy exist in 10 or 11 total dimensions, with the familiar 4 dimensions of space-time representing merely the large-scale projection of a far more complex geometric reality that extends into realms where distance and direction follow rules completely alien to 3-dimensional intuition. These extra dimensions could be curled up in countless different ways, each geometric configuration producing different effective physics in the resulting 4-dimensional space-time that we experience as reality. The Calabi-Yau manifolds that mathematicians use to describe these compactified dimensions possess intricate topologies with holes, handles, and twisted surfaces that create complex internal landscapes where hypothetical beings adapted to higher dimensional existence might navigate through spatial relationships that have no analog in our familiar world of up and down, left and right, forward and backward. If matter and energy can exist within these compactified dimensions, entire ecosystems might flourish in spaces smaller than atomic nuclei, complete with their own versions of stars, planets, and perhaps even forms of life that evolved according to physical laws determined by the specific geometry of their higher dimensional environment. These microscopic universes would operate according to the same fundamental principles that govern our familiar cosmos. But the altered geometry of space itself would create different relationships between matter, energy, gravity, and electromagnetic forces that could support exotic forms of chemistry and biology. The concept of brain-world cosmology suggests that our entire universe might exist as a three-dimensional membrane floating within a higher dimensional space called the bulk, separated from other parallel branes that harbor their own versions of matter, energy, and physical laws. Gravitational forces, which appear to be the weakest of the fundamental forces in our three-dimensional experience, might actually possess the same intrinsic strength as electromagnetic and nuclear forces, but seem weak because gravity can leak into the extra dimensions, while other forces remain confined to our three-dimensional brain. Recent experiments designed to test whether gravity follows the familiar inverse square law at a very small distance scales have found tantalizing hints that gravitational attraction might indeed become stronger than expected when measured between objects separated by distances smaller than a millimeter. These deviations from Newton's law of universal gravitation could indicate that gravitational force lines spread into extra dimensions at short ranges, providing the first experimental evidence that higher dimensional spaces exist and influence physical phenomena in our familiar three-dimensional world. The hierarchy problem in particle physics provides another compelling reason to suspect that extra dimensions play a crucial role in determining the structure of reality at its most fundamental level. The enormous difference between the strength of gravity and the other fundamental forces requires explanation through either extremely fine-tuned parameters in our theories or through mechanisms that naturally suppress gravitational effects in three dimensions while allowing them to operate at full strength in higher dimensional spaces. Extra dimensions provide an elegant solution to this puzzle by allowing gravity to spread into geometric realms that remain inaccessible to matter and energy confined to our three-dimensional brain. Quantum mechanics adds another layer of mystery to the possibility of hidden dimensions through the uncertainty principle, which suggests that virtual particles constantly pop into existence from the vacuum of empty space before annihilating each other in timescales too brief for direct detection. Some theoretical models propose that these virtual particles might briefly explore higher dimensional spaces during their fleeting existence, carrying information about the geometry and physics of extra dimensions back into our familiar three-dimensional realm through quantum fluctuations that influence the behavior of ordinary matter and energy. The cosmological constant problem, which attempts to explain why the observed expansion rate of the universe differs from theoretical predictions by a factor of 10 to the power of 120, might find resolution through extra-dimensional mechanisms that cancel out most of the vacuum energy that would otherwise cause space to expand at catastrophically rapid rates. This fine-tuning between positive and negative contributions to cosmic expansion suggests that our universe exists in a delicate balance maintained by physical processes operating in higher dimensional spaces that remain completely hidden from direct observation. Advanced civilizations that evolved in universes with direct access to extra dimensions might possess technologies that seem impossible from our three-dimensional perspective, including forms of transportation that take shortcuts through higher dimensional spaces to travel between distant locations in our familiar three-dimensional universe. These beings might perceive our entire cosmos as we perceive a two-dimensional shadow cast by a three-dimensional object, understanding aspects of reality that remain forever hidden from creatures confined to lower-dimensional existence. The possibility that parallel Earths exist in adjacent extra dimensions creates scenarios where alternate versions of our planet might occupy the same three-dimensional coordinates as our familiar world, while remaining completely inaccessible due to the different geometric configurations of their compactified dimensions. These parallel worlds could share identical histories up to quantum branch points where different outcomes occurred, creating infinite variations on familiar themes where slightly different physics produces dramatically different evolutionary outcomes. Experimental searches for extra dimensions continue through high-energy particle accelerator experiments that attempt to create conditions extreme enough to probe the structure of space at the smallest possible scales. The Large Hadron Collider looks for signatures of extra-dimensional physics in the debris of high-energy particle collisions, searching for missing energy that might have escaped into hidden dimensions or for the production of exotic particles that could only exist in higher dimensional spaces. These experiments push the boundaries of human technology in attempts to detect phenomena that exist just beyond the threshold of current instrumental sensitivity. Gravitational wave detectors like LIGO and Virgo have opened new windows into the fundamental structure of space-time by measuring tiny distortions in the fabric of space itself as gravitational waves pass through Earth. Future gravitational wave observatories might detect subtle signatures of extra-dimensional physics through anomalies in how gravitational waves propagate through space, potentially revealing whether gravity leaks into hidden dimensions during its journey across cosmic distances measured in billions of light years. The mathematics of higher dimensional geometry suggests that if conscious beings evolved within compactified extra dimensions, their perceptual and cognitive capabilities might surpass three-dimensional intelligence in ways that remain difficult to imagine from our limited perspective confined to length, width, height, and time. These higher dimensional beings might perceive our entire universe as easily as we perceive the surface of a sphere. Understanding relationships and patterns that remain forever hidden from three-dimensional consciousness, while existing in spaces so small that trillions of their complete civilizations could coexist within the volume of a single atom. The universe's preference for hidden complexity over obvious simplicity suggests that extra dimensions represent only the beginning of spatial relationships that extend beyond human perception into realms where geometry itself becomes a living, dynamic aspect of reality that shapes the emergence of consciousness, intelligence, and perhaps forms of existence that transcend the distinction between matter and space, energy and time. Observer and observed in patterns that unfold across dimensions whose very existence challenges our most basic assumptions about the nature of space, distance, and the meaning of location in a cosmos where here and there become relative concepts determined by which dimensional projection we happen to inhabit, while surrounded by infinite parallel realms separated by distances smaller than the wavelength of visible light, yet as real and complex as the familiar world, where we pause to contemplate the possibility that other forms of consciousness might exist just beyond the reach of three-dimensional perception. The transit method that has revealed thousands of exoplanets operates like cosmic shadow play, detecting worlds only when they pass directly between their host stars and Earth's telescopes, creating brief dimming events that last from minutes to hours, depending on the planet's size and orbital velocity. This geometric constraint means that most planetary systems remain invisible to our current detection techniques, their orbital planes tilted at angles that never bring their planets into alignment with our line of sight across the vast distances that separate star systems throughout the galaxy's spiral arms. Statistical analysis suggests that only roughly half of 1% of all planetary systems are oriented correctly for transit detection from Earth's perspective, meaning that for every confirmed exoplanet discovered through the transit method, approximately 200 similar worlds orbit their stars at inclinations that keep them forever hidden from our instruments. The Kepler Space Telescope, during its primary mission, monitored 150,000 stars continuously for over 4 years, yet detected confirmed planets around fewer than 3,000 of these stellar targets, implying that tens of thousands of additional planetary systems likely exist within Kepler's field of view, but remain undetectable due to unfavorable orbital geometry. This observational bias becomes particularly pronounced for Earth-sized planets orbiting within the habitable zones of Sun-like stars. Since these worlds require orbital periods of roughly 1 year and produce transit signals lasting only 10 to 16 hours once every 365 days. Ground-based telescopes cannot maintain the continuous monitoring required to detect such infrequent and brief events, while space-based observatories must stare at the same patch of sky for multiple years to confirm planetary candidates through repeated transit observations that verify orbital periods and rule out false positive signals caused by eclipsing binary stars or other astrophysical phenomena. The radial velocity method, which detects planets through the subtle gravitational tugs they exert on their host stars, faces complementary limitations that favor the discovery of massive planets in close orbits while struggling to detect Earth-mass worlds at Earth-like distances from Sun-similar stars. Current radial velocity instruments can measure stellar motion to precisions of roughly 1 meter per second, but Earth's gravitational influence on the Sun produces velocity variations of only 9 centimeters per second with a period of 1 year. Placing Earth analog detection just beyond the threshold of current technological capabilities and requiring years of continuous observations to accumulate sufficient data for statistical confirmation. Direct imaging of exoplanets remains the most challenging detection method due to the enormous brightness contrast between planets and their host stars, with typical Earth-like worlds appearing roughly 10 billion times dimmer than their parent stars when observed in visible light. This contrast ratio resembles attempting to photograph a firefly hovering next to a searchlight from a distance of thousands of kilometers, requiring coronagraph instruments capable of blocking starlight with unprecedented precision while preserving the faint reflected light from planetary surfaces and atmospheres. The recently launched James Webb Space Telescope has demonstrated the capability to directly image massive planets orbiting far from bright stars. But Earth-sized worlds at habitable zone distances remain beyond its detection limits due to insufficient angular resolution and residual scattered light from stellar coronagraph systems. Future space telescopes specifically designed for exoplanet characterization will require primary mirrors 30 to 40 meters in diameter, deployed using revolutionary engineering techniques that allow segmented mirror assemblies to unfold and align with nanometer precision in the zero-gravity environment of deep space. Gravitational microlensing surveys have revealed a population of free-floating planets ejected from their birth systems during chaotic early phases of planetary formation, wandering through interstellar space without any host star to illuminate their surfaces or warm their atmospheres. These rogue worlds remain completely invisible to transit and radial velocity searches, while producing detectable microlensing events only when they pass between Earth and background stars in rare geometric alignments that create temporary magnification of distant starlight through gravitational focusing effects. Recent estimates suggest that free-floating planets might outnumber stars in our galaxy, implying that billions of dark worlds drift through the spaces between stellar systems, carrying whatever internal heat they retained from their formation process, or generated through radioactive decay in their cores. Some of these nomadic planets might be Earth-sized, maintaining subsurface oceans beneath kilometers of ice that could support ecosystems completely isolated from stellar energy sources and invisible to any astronomical survey designed to detect planets through their relationships with host stars. The astrometric method, which attempts to detect planets through their gravitational effects on stellar positions measured against the background of distant stars, requires angular precision approaching microarc seconds to detect Earth-mass planets orbiting Sun-like stars at distances comparable to Earth's orbital radius. This level of measurement precision pushes against fundamental limits imposed by atmospheric turbulence for ground-based telescopes and thermal fluctuations in spacecraft structures for space-based observatories, demanding engineering solutions that have not yet been demonstrated in operational astronomical instruments. Pulsar timing arrays offer unique capabilities for detecting planets around neutron stars through the effects of planetary gravitational fields on the precisely regular radio pulses emitted by these stellar remnants. However, the extreme radiation environments around pulsars preclude the existence of life as we understand it, making pulsar planets fascinating astrophysical laboratories for studying planetary formation under exotic conditions, but unlikely candidates for harboring familiar forms of biology or chemistry capable of supporting complex ecosystems. The velocity of light creates additional observational challenges for exoplanet detection and characterization, since signals from potentially habitable worlds require years or decades to travel across the interstellar distances that separate neighboring star systems. Any atmospheric or surface changes occurring on nearby exoplanets today will not become observable from Earth until the corresponding light has completed its journey across the light years of intervening space, creating fundamental delays between cosmic events and their detection that increase proportionally with astronomical distance. Atmospheric characterization of potentially habitable exoplanets requires spectroscopic analysis of starlight filtered through planetary atmospheres during transit events. But this technique works only for worlds that happen to transit particularly bright stars, while possessing atmospheres thick enough to produce detectable absorption features in their transmission spectra. Most potentially habitable planets orbit stars too dim for detailed atmospheric analysis using current instruments, while others possess atmospheric compositions or structures that remain invisible to spectroscopic techniques optimized for detecting water vapor, carbon dioxide, and other molecules associated with terrestrial-type atmospheres. The search for biosignatures in exoplanet atmospheres faces additional complications from false positive signals that could mimic the chemical signatures of life through non-biological processes. Oxygen, often considered a primary biosignature gas, can be produced through photodissociation of water molecules in planetary upper atmospheres, while methane might result from geological processes rather than biological metabolism. Distinguishing between biotic and abiotic sources of potential biosignature gases requires simultaneous detection of multiple atmospheric constituents in chemical ratios that would be difficult to maintain through non-living processes alone. Interstellar dust and gas clouds scattered throughout the galaxy create additional observational challenges by absorbing and scattering light from distant star systems, reducing the apparent brightness of potential planetary transit signals and introducing systematic errors into photometric measurements that must be carefully calibrated and corrected. Dense molecular clouds can completely obscure entire regions of the galaxy from optical observation, hiding thousands of star systems that might harbor Earth-like worlds in their gravitationally bound collections of planets, asteroids, and comets. The finite lifetimes of space-based telescopes impose practical limits on how long astronomers can monitor individual star systems for rare transit events or subtle radial velocity variations that indicate the presence of Earth-analog planets. Fuel requirements for maintaining precise pointing and orbital stability typically limit mission durations to 5 to 10 years, while the degradation of sensitive detector arrays under cosmic radiation exposure gradually reduces instrumental precision over timescales comparable to the orbital periods of potentially habitable planets around Sun-like stars. Future astronomical surveys will require revolutionary advances in detector sensitivity, coronagraph design, and space-based engineering to overcome the fundamental observational challenges that currently hide most potentially habitable exoplanets from direct detection and characterization. These technological developments might eventually reveal that Earth-like worlds are common throughout our cosmic neighborhood, orbiting quietly around stars whose faint light carries the reflected signatures of continents, oceans, and perhaps even vegetation that remains invisible to current instruments while existing just beyond the threshold of human detection in a universe where the majority of worlds continue to spin through their days and nights unobserved by distant telescopes that search patiently for signs of cosmic neighbors in the darkness between stars that burn with light too dim to illuminate the hidden complexity of planetary systems scattered throughout the galaxy's vast collection of matter and energy, organized into patterns that await discovery by future generations equipped with instruments sensitive enough to detect the subtle signals that carry information about worlds as real and detailed as Earth, yet separated by distances that measure the true scale of space in a cosmos where proximity becomes a relative concept determined by the reach of human technology, rather than the actual abundance of places where liquid water might flow beneath alien skies that reflect the same starlight that illuminates our own familiar horizons. Mirror matter theory proposes that every fundamental particle in our familiar universe possesses a corresponding mirror partner that interacts through mirror versions of the electromagnetic, weak nuclear, and strong nuclear forces while sharing only gravitational interactions with ordinary matter. These mirror particles would form their own complete periodic table of mirror elements, supporting mirror chemistry that operates according to principles parallel to, but completely separate from the chemical processes that drive life on Earth, creating the possibility for entire mirror ecosystems that coexist with our familiar world while remaining completely invisible to instruments designed to detect electromagnetic radiation or nuclear interactions. The mathematical symmetry between matter and mirror matter emerges naturally from certain extensions of the standard model of particle physics, particularly theories that attempt to explain the observed asymmetry between matter and antimatter in the observable universe. If mirror matter exists in quantities comparable to ordinary matter, it could account for a significant fraction of the dark matter that comprises roughly 27% of the universe's total mass energy budget, providing a concrete physical mechanism for the invisible gravitational influence that shapes galactic rotation curves and cosmic structure formation across billions of years of cosmic evolution. Mirror photons would carry electromagnetic radiation through mirror matter structures in ways that remain completely undetectable to ordinary matter instruments, creating the possibility for mirror stars that burn through mirror nuclear fusion processes while emitting mirror light that illuminates mirror planetary systems where mirror chemistry supports mirror biology. These parallel stellar ecosystems would exist in the same regions of space occupied by familiar galaxies, while operating according to physical laws that interact with our observable universe only through the patient pull of gravity across distances measured in light years. Laboratory experiments designed to detect mirror matter interactions have searched for subtle violations of energy and momentum conservation that might occur when ordinary particles convert into mirror particles through rare quantum processes, or when mirror matter objects pass through terrestrial matter without producing any electromagnetic or nuclear signatures. High-energy particle accelerator experiments look for missing energy and momentum that might have been carried away by mirror particles produced in collision events, while precision measurements of gravitational forces search for anomalous attractions that could indicate the presence of mirror matter concentrations in Earth's vicinity. The neutron oscillation experiments conducted at several national laboratories attempt to detect the theoretical possibility that ordinary neutrons might spontaneously convert into mirror neutrons under specific conditions, particularly when isolated from magnetic fields that could suppress the mixing between ordinary and mirror quantum states. These experiments store ultra-cold neutrons in magnetic bottle traps for extended periods, while monitoring whether the neutron population decreases more rapidly than expected from known decay processes. Searching for evidence that some neutrons disappear by transitioning into mirror matter, states that become invisible to ordinary matter detectors. Mirror matter cosmology suggests that mirror nucleosynthesis during the first few minutes after the Big Bang would have produced mirror hydrogen, mirror helium, and trace amounts of heavier mirror elements according to the same nuclear physics that determined the primordial abundances of ordinary light elements. These mirror materials would subsequently condense into mirror molecular clouds, mirror stars, and mirror planetary systems that follow the same gravitational collapse and accretion processes that shaped the formation of familiar cosmic structures while remaining completely dark to optical, radio, and X-ray astronomy. The possibility that Earth exists within a region of space that also contains mirror matter raises intriguing questions about potential gravitational interactions between ordinary and mirror planetary systems. Mirror planets orbiting mirror stars could occupy the same general region of the galaxy as our solar system, while following completely independent orbital dynamics that occasionally bring mirror worlds into gravitational alignment with ordinary planets, creating subtle perturbations in orbital mechanics that might be detectable through precision measurements of planetary positions and asteroid trajectories over decades of careful observation. Mirror supernovae would produce gravitational waves detectable by current gravitational wave observatories, while remaining completely invisible to electromagnetic surveys designed to detect ordinary stellar explosions through their optical, radio, and gamma-ray emissions. The LIGO and Virgo gravitational wave detectors might have already observed mirror neutron star mergers or mirror black hole coalescence events without recognizing their mirror matter origins. Since gravitational waves carry the same signatures regardless of whether their sources consist of ordinary matter or mirror matter components, theoretical models of mirror matter interactions predict that ordinary and mirror matter might exchange energy through gravitational heating during close encounters between ordinary and mirror astronomical objects, potentially explaining some of the anomalous heat sources observed in certain planetary atmospheres and stellar systems. The gradual orbital decay of binary star systems might proceed more rapidly than expected if unseen mirror matter companions extract energy from ordinary matter systems through gravitational interactions that remain invisible to electromagnetic observation while producing measurable effects on orbital dynamics. Mirror matter life forms would evolve according to the same basic principles that govern terrestrial biology, but using mirror versions of carbon, hydrogen, oxygen, nitrogen, and other elements essential for complex chemistry and information storage. Mirror DNA would encode genetic information using mirror nucleotides that follow the same base pairing rules as ordinary DNA while remaining chemically inert when mixed with ordinary biological molecules, creating the possibility for mirror ecosystems that coexist with terrestrial life while operating according to completely separate evolutionary pressures and environmental constraints. The search for mirror matter continues through increasingly sophisticated experiments that attempt to detect the subtle gravitational and cosmological signatures that would indicate its presence throughout the universe. Precision measurements of the cosmic microwave background radiation look for small-scale temperature fluctuations that might result from mirror matter gravitational effects during the epoch of cosmic structure formation, while surveys of galactic dynamics search for gravitational anomalies that could indicate the presence of mirror matter concentrations within the Milky Way's spiral arms. Mirror matter planets might maintain their own complex atmospheric circulation patterns, weather systems, and climate cycles driven by mirror stellar radiation and mirror greenhouse effects, creating mirror environments where mirror life forms adapt to mirror seasonal variations and mirror climate changes over geological timescales. These mirror biospheres would develop their own versions of photosynthesis, respiration, and ecological relationships while remaining completely invisible to any search for extraterrestrial life based on detecting familiar chemical signatures or electromagnetic emissions. The theoretical possibility that ordinary matter and mirror matter might undergo rare conversion processes under extreme conditions creates scenarios where information could potentially be exchanged between ordinary and mirror sectors through carefully designed experiments or natural astrophysical events. High-energy cosmic ray interactions, neutron star magnetic field environments, or the extreme space-time curvature near black hole event horizons might provide sufficient energy density to facilitate particle conversions that would otherwise remain forbidden by conservation laws operating under normal terrestrial conditions. Future experiments designed to detect mirror matter might exploit the predicted gravitational interactions between ordinary and mirror matter through precision measurements of gravitational anomalies in laboratory settings or astronomical observations. These searches require unprecedented sensitivity to tiny gravitational effects that could indicate the presence of mirror matter concentrations, demanding technological advances in gravitational wave detection, atomic interferometry, and precision accelerometry that push against fundamental limits imposed by quantum mechanical uncertainties and thermal noise in mechanical systems. The universe's apparent preference for symmetry and mathematical elegance suggests that if mirror matter exists, it likely forms structures and patterns that parallel the complexity and diversity observed in ordinary matter systems while remaining forever hidden from direct electromagnetic observation. Mirror galaxies, mirror star clusters, and mirror planetary nebulae would sculpt the same gravitational landscapes that shape ordinary cosmic evolution, while supporting mirror civilizations that might contemplate the possibility of ordinary matter, counterparts existing alongside their own mirror reality in a cosmos where two complete universes share the same space-time continuum while interacting only through the universal language of gravity that connects all forms of matter and energy across the infinite spaces where ordinary and mirror worlds spin through their separate but parallel histories under the patient influence of forces that operate according to identical mathematical principles yet remain forever separated by the fundamental asymmetries that distinguish matter from its hidden mirror reflection in the depths of space, where darkness conceals forms of complexity as real and detailed as any structure visible to telescopes that search for signs of cosmic companions in a universe that might be twice as populated with conscious beings as we have ever dared to imagine, while remaining twice as mysterious as we currently understand. Within 100 light-years of Earth, a cosmic census reveals dozens of potentially habitable worlds orbiting quietly in their stars' temperate zones, each one spinning through days and nights that might feel familiar to travelers from our own small planet, yet possessing unique combinations of size, atmospheric composition, and orbital characteristics that could support forms of life adapted to conditions ranging from perpetual twilight around red dwarf stars to the seasonal rhythms of worlds circling sun-like stellar companions. This stellar neighborhood, containing roughly 14,000 stars of various masses and ages, represents a tiny fraction of our galaxy's 400 billion stellar members, yet provides a representative sample of the planetary systems that populate interstellar space throughout the Milky Way's spiral arms. Kepler 442b, located 68 light-years from Earth in the constellation Lyra, orbits within the conservative habitable zone of its K-type star every 112 days, receiving stellar radiation intensity roughly 70% that of Earth while maintaining a mass approximately twice that of our home planet. Computer models suggest this super-Earth possesses sufficient gravitational attraction to retain thick atmospheres capable of supporting substantial greenhouse warming, potentially maintaining surface temperatures suitable for liquid water across continental landmasses, even at its relatively distant orbital position. The planet's increased surface gravity would create atmospheric pressure profiles and circulation patterns significantly different from Earth's familiar weather systems, while still permitting the existence of stable climate zones where complex chemistry could flourish. HD 40307G, discovered through radial velocity measurements of a star 42 light-years distant, represents one of the most promising candidates for Earth-like conditions within our immediate cosmic vicinity. This super-Earth, with a minimum mass roughly 7 times that of Earth, orbits in the outer regions of its star's habitable zone with a period of 197 days, receiving sufficient stellar energy to maintain temperate surface conditions if it possesses an atmosphere with modest greenhouse gas concentrations. The planet's host star, slightly less massive and cooler than our Sun, provides stable energy output over billions of years while producing relatively few harmful stellar flares that could strip away planetary atmospheres over geological timescales. Wolf 1061. C. Orbiting a red dwarf star just 13.8 light-years from Earth, completes its journey around its dim stellar companion every 17.9 days while remaining within the narrow zone where surface temperatures could permit liquid water to exist on rocky planetary surfaces. This tidally locked world presents one hemisphere perpetually toward its star while the other side experiences endless night, creating extreme temperature gradients that could drive powerful atmospheric circulation patterns capable of redistributing heat from the day side to the night side through global wind systems and cloud formation processes that might create habitable twilight zones around the planet's terminator region. The TRAPPIST-1 system, located 39 light-years away, contains 7 Earth-sized planets packed into orbits closer than Mercury's distance from our Sun, with 3 of these worlds positioned within the habitable zone where liquid water could persist on their surfaces. TRAPPIST-1 E. The most Earth-like member of this tightly packed planetary family receives stellar radiation comparable to Earth's solar input while maintaining a density suggesting rocky composition similar to terrestrial planets. The system's compact architecture creates complex gravitational interactions between neighboring worlds that could drive tidal heating in planetary interiors, maintaining geological activity that keeps atmospheres replenished with volcanic gases essential for long-term climate stability. Proxima Centauri. Be humanity's closest confirmed exoplanetary neighbor at just 4.2 light-years distant, orbits within the habitable zone of the nearest star to our solar system every 11.2 days. Though its tidally locked nature and exposure to stellar flare activity create environmental challenges that require careful atmospheric modeling to assess its potential for supporting liquid water and complex chemistry. Recent observations suggest the planet might possess substantial atmospheric mass, potentially including water vapor that could condense into precipitation under the right temperature and pressure conditions, despite the harsh radiation environment characteristic of close orbiting planets around red dwarf stars. Kepler 1649c, discovered in archived data from the completed Kepler mission, orbits a red dwarf star 300 light-years away while receiving stellar radiation almost identical to Earth's solar input and maintaining a size only 6% larger than our home planet. This near-Earth twin represents one of the most promising candidates for truly Earth-like conditions yet discovered, though its 19.5-day orbital period around a red dwarf star creates the familiar challenges of tidal locking and stellar flare exposure that characterize most potentially habitable planets around the galaxy's most common type of star. The statistical distribution of these nearby potentially habitable worlds suggests that rocky planets in temperate zones represent a common outcome of planetary formation processes throughout the galaxy, with roughly 1 in 5 Sun-like stars hosting Earth-sized worlds within orbital distances that permit liquid water to exist on planetary surfaces. Red dwarf stars, which comprise roughly 75% of all stellar objects in our galaxy, appear to host rocky planets even more frequently. Though the habitability of these worlds remains uncertain due to the extreme stellar environments and tidal locking effects that characterize close planetary orbits around low-mass stars, recent advances in exoplanet atmospheric characterization have begun to reveal the chemical compositions of some nearby, potentially habitable worlds through transit spectroscopy and direct emission measurements. Though these techniques remain limited to planets that transit particularly bright stars or orbit at favorable angles for detailed observation, water vapor, carbon dioxide, and methane have been detected in the atmospheres of several nearby exoplanets, providing the first concrete evidence that familiar atmospheric chemistry operates on worlds orbiting distant stars within our cosmic neighborhood. The diversity of potentially habitable environments within 100 light-years of Earth encompasses worlds orbiting single stars, binary star systems, and multiple star configurations that create complex seasonal patterns and variable stellar radiation environments. Some of these planets experience double sunsets and variable day lengths as they orbit one member of a binary star pair while receiving additional heating from the companion star, creating climate systems more complex than any found in our single-star solar system, yet potentially stable enough to support long-term biological evolution. Atmospheric circulation models for super-Earths with masses several times that of our planet predict enhanced greenhouse effects and more vigorous weather systems driven by increased gravitational energy and thicker atmospheric mass, potentially creating global climates more stable than Earth's while supporting greater atmospheric pressure that could facilitate more efficient heat distribution between day and night sides of tidally locked worlds. These enhanced atmospheric dynamics might create habitable conditions on planets that would otherwise be too hot or too cold to support liquid water based on simple radiation balance calculations. The ages of nearby potentially habitable planetary systems range from recently formed worlds around young stars to ancient planetary families that have existed for over 10 billion years, twice the current age of our solar system and Earth's biosphere. These ancient worlds have had vast amounts of time for life to emerge, evolve, and potentially develop technological civilizations. Though the absence of detectable artificial signals from any nearby star systems suggests that either intelligent life remains rare or advanced civilizations prefer communication methods that remain invisible to current human technology. Ground-based and space-based surveys continue to discover additional potentially habitable worlds within our cosmic neighborhood through improved detection techniques and longer baseline observations that reveal planets with orbital periods comparable to Earth's year around Sun-like stars. The recently launched Transiting Exoplanet Survey satellite has identified numerous new candidates for detailed follow-up observations, while the James Webb Space Telescope has begun atmospheric characterization of the most promising nearby worlds through spectroscopic analysis of their thermal emission and reflected starlight. The possibility that multiple potentially habitable worlds exist within relatively short interstellar distances creates scenarios where future human space exploration might eventually visit several Earth-like planets within a single cosmic generation. Comparing different solutions to the challenges of maintaining liquid water, stable climates, and complex chemistry under varying stellar radiation environments and planetary characteristics, these comparative studies of nearby habitable worlds could provide unprecedented insights into the factors that determine whether planets develop and maintain conditions suitable for life over geological timescales. Perhaps most remarkably, the cosmic census of nearby potentially habitable worlds suggests that Earth exists within a relatively densely populated region of the galaxy where dozens of worlds capable of supporting complex chemistry and possibly life orbit within distances that future technologies might eventually bridge through interstellar exploration missions. The universe's apparent abundance of temperate rocky planets implies that the basic ingredients for habitability, liquid water, stable energy sources, and chemical complexity represent common features of planetary evolution rather than rare cosmic accidents, creating a galactic environment where Earth-like worlds might exist as frequently as islands scattered across a vast ocean, each one harboring its own unique version of the physical and chemical processes that make planets suitable for the emergence and evolution of life under alien stars that burn with light as warm and steady as our own sun's patient radiance, illuminating the familiar world where we pause to contemplate the possibility that countless other beings might look up at their own night skies and wonder about the existence of distant companions spinning through the darkness between stars that connect all, potentially habitable worlds in a cosmic community whose true extent remains limited only by the reach of future exploration technologies and the persistence of conscious beings who dare to imagine what lies beyond the horizon of current discovery in a universe that appears to favor complexity over simplicity and life over lifelessness across the patient expanse of space and time that separates all worlds, yet connects them through the universal laws that govern matter and energy in their endless dance toward greater organization and awareness. Quantum tunneling through reality operates according to principles so strange that individual particles regularly phase between parallel quantum states, disappearing from one version of reality and reappearing in another without crossing the intervening space in any classically comprehensible manner. This fundamental quantum mechanical process occurs billions of times per second in every atom within our bodies, as electrons tunnel through energy barriers that classical physics insists should be insurmountable, creating the chemical bonds that hold molecules together and the nuclear reactions that power stellar fusion, while simultaneously suggesting that the boundary between different versions of reality might be far more permeable than our everyday experience indicates. The mathematics of quantum mechanics describes reality as a vast collection of probability waves that encode all possible outcomes of every measurement or interaction, with conscious observation causing these waves to collapse into specific concrete results that define the particular version of reality we experience. Yet the equation suggests that unobserved quantum systems continue to exist in superposition states where all possible outcomes remain equally real, creating parallel branches of reality that diverge from our observed timeline yet maintain the same fundamental validity according to the mathematical structure that governs quantum behavior at the smallest scales of space and time. Wave function collapse, the process by which quantum superposition states resolve into definite outcomes when measured or observed, might represent only a subjective phenomenon experienced by conscious observers trapped within specific quantum branches rather than a fundamental feature of reality itself. The many worlds interpretation of quantum mechanics, proposed by physicist Hugh Everett in 1957, suggests that every possible outcome of every quantum measurement actually occurs in parallel universes that split off from each other like branches of an infinite tree, with conscious observers experiencing only one path through this branching structure while remaining unaware of the countless alternate versions of themselves following different trajectories through the quantum multiverse. Quantum entanglement creates instantaneous correlations between particles separated by arbitrary distances, allowing measurements performed on one member of an entangled pair to immediately influence the quantum state of its partner regardless of the spatial separation between them. This phenomenon, which Einstein famously dismissed as spooky action at a distance, has been confirmed through thousands of laboratory experiments and forms the basis for emerging technologies like quantum computing and quantum cryptography. Yet, its implications for the nature of space, time, and reality itself remain profoundly mysterious and potentially revolutionary for our understanding of cosmic structure. Recent experiments in quantum teleportation have demonstrated the ability to transfer quantum information between distant locations without sending any particle or signal through the intervening space, effectively recreating the exact quantum state of one system in a completely separate location while destroying the original state in the process. These teleportation protocols suggest that information, rather than matter or energy, might represent the most fundamental aspect of reality, with particles and forces emerging as secondary phenomena that arise from underlying patterns of quantum information organized according to mathematical principles that operate beyond the familiar constraints of three-dimensional space and linear time. The quantum Zeno effect demonstrates that frequent measurements of a quantum system can effectively freeze its evolution, preventing quantum state changes that would normally occur through natural quantum mechanical processes. This observer-dependent alteration of physical reality suggests that consciousness plays a more fundamental role in determining the structure of the universe than classical physics ever anticipated, potentially creating feedback loops where conscious observation shapes the very quantum processes that give rise to the material world that supports conscious observers in a cosmic cycle of mutual influence and determination. Quantum tunneling allows particles to penetrate energy barriers that should be completely impermeable according to classical mechanics, enabling nuclear fusion reactions in stellar cores at temperatures far below the energy thresholds required for classical particles to overcome electrostatic repulsion between atomic nuclei. This quantum mechanical effect makes stellar evolution and the formation of heavy elements possible, while demonstrating that reality operates according to probabilistic rather than deterministic principles at its most fundamental level. The same quantum tunneling processes that power the sun might also allow particles to tunnel between parallel quantum realities separated by energy barriers in abstract mathematical spaces that exist beyond the familiar dimensions of length, width, height, and time. Laboratory experiments with quantum interference have shown that individual photons and electrons can simultaneously travel through multiple paths in interferometer setups, creating interference patterns that can only be explained if each particle somehow experiences all possible routes through the experimental apparatus at the same time. These results suggest that quantum objects exist in multiple parallel states until the moment of measurement forces them to choose a single definite path, implying that reality itself might consist of overlapping layers of possibility that remain superimposed until conscious observation selects one particular version for direct experience. The delayed choice quantum eraser experiments, first proposed by physicist John Wheeler, demonstrate that quantum measurements performed in the future can retroactively determine the past behavior of photons, apparently violating the classical notion that causality flows strictly from past to future. These experiments suggest that the boundary between past and future might be far more fluid in quantum reality than our everyday experience indicates, creating scenarios where future quantum measurements could potentially influence past events, or where alternate versions of history might remain accessible through quantum mechanical pathways that connect different moments in time. Quantum computing harnesses the strange properties of quantum superposition and entanglement to perform calculations that would be impossible using classical computers, exploiting the ability of quantum bits to exist in multiple states simultaneously to explore vast numbers of possible solutions in parallel before collapsing into the optimal answer through carefully orchestrated measurement procedures. These quantum computational processes suggest that reality itself might operate like a vast quantum computer, continuously calculating all possible outcomes of every interaction before selecting specific results through the mysterious process of wave function collapse that remains one of the deepest unsolved problems in modern physics. The quantum vacuum, far from being empty space, seethes with virtual particle pairs that continuously pop into existence and annihilate each other in time intervals so brief they remain undetectable through direct measurement, yet produce measurable effects like the Casimir force that pushes parallel conducting plates together in laboratory experiments. These virtual particles might represent brief glimpses into parallel quantum realities where different conservation laws operate, or where the same particles exist as permanent rather than temporary features of alternative quantum vacuum states that remain hidden behind the uncertainty principle's fundamental limits on simultaneous measurement of complementary physical properties. Quantum field theory describes all fundamental particles as excitations in underlying quantum fields that permeate every point in space and time, suggesting that what we perceive as discrete objects actually represent wave-like disturbances in a more fundamental reality composed entirely of mathematical relationships between abstract field values. This field-theoretic picture of reality implies that consciousness, matter, energy, and space-time itself might all emerge from deeper quantum mechanical processes that operate according to principles we are only beginning to understand through mathematical formalism that describes but does not yet explain the mechanisms by which quantum information organizes itself into the complex structures we recognize as physical reality. Bell's theorem and its experimental verification through tests of Bell's inequality have proven that no theory based on local realism can reproduce the statistical predictions of quantum mechanics, forcing physicists to abandon either the assumption that physical properties exist independently of measurement or the assumption that influences cannot travel faster than light. This fundamental limitation on classical explanations of quantum behavior suggests that reality operates according to non-local principles that connect distant events through mechanisms that transcend the familiar structure of space and time, potentially creating channels of communication or influence between parallel quantum realities that exist in mathematical spaces beyond three-dimensional geometry. Quantum error correction, developed for protecting quantum information from environmental decoherence in quantum computers, demonstrates that quantum states can be preserved and manipulated with remarkable precision despite the fragility of quantum superposition in the presence of external disturbances. These error correction protocols suggest that nature itself might employ similar quantum error correction mechanisms to maintain the stability of physical laws and mathematical relationships across cosmic timescales, preventing the quantum mechanical foundation of reality from decohering into random noise while preserving the coherent information patterns that give rise to galaxies, stars, planets, and conscious observers. The measurement problem in quantum mechanics, which attempts to explain how and why quantum superposition states collapse into definite outcomes during measurement processes, remains one of the most profound unsolved mysteries in modern physics, despite nearly a century of theoretical development and experimental verification of quantum mechanical predictions. Various interpretations propose that consciousness, environmental decoherence, or hidden variable theories might explain wave function collapse. Yet none of these explanations has achieved universal acceptance among physicists, leaving open the possibility that reality operates according to principles more strange and wonderful than current scientific paradigms can accommodate. Recent theoretical work on quantum gravity suggests that space and time themselves might emerge from more fundamental quantum mechanical processes that operate in abstract mathematical spaces where the familiar concepts of distance, duration, and causality become approximate descriptions valid only at macroscopic scales. These theories imply that the quantum tunneling processes observed in atomic and subatomic systems might represent manifestations of deeper geometric principles that allow transitions between different regions of a vast mathematical landscape where each point corresponds to a different possible version of physical reality with its own unique laws, constants, and historical evolution. The possibility that conscious observers might influence quantum mechanical processes through the act of measurement creates scenarios where alternate versions of reality remain accessible through carefully designed quantum experiments that exploit the observer-dependent nature of wave function collapse. Advanced civilizations that developed complete understanding of quantum mechanics might possess technologies that allow controlled tunneling between parallel quantum realities, enabling exploration of alternate histories where different quantum measurements produced different outcomes while preserving quantum coherence across multiple parallel states simultaneously. Future developments in quantum technology might eventually allow direct manipulation of the quantum vacuum structure that underlies physical reality, potentially creating artificial wormholes, time loops, or parallel universe interfaces that operate through quantum tunneling processes, scaled up from atomic dimensions to macroscopic engineering projects. These speculative technologies would require mastery of quantum field theory applications that remain far beyond current human capabilities, yet might represent natural developments for civilizations that evolved within universes where quantum mechanical principles operate more transparently than in our familiar reality, where quantum effects remain hidden behind the classical appearance of everyday experience. The universe's apparent preference for mathematical elegance and quantum mechanical consistency suggests that the strange principles governing quantum tunneling might represent only the simplest examples of reality's fundamental tendency toward impossible possibilities and paradoxical connections between seemingly separate aspects of existence. As conscious beings embedded within quantum reality, we might represent the universe's attempt to understand its own quantum mechanical nature through the emergence of observers capable of performing the measurements and calculations that cause quantum superposition states to collapse into the definite outcomes that define the particular version of reality we experience, while remaining forever connected to the infinite collection of parallel worlds where alternate versions of quantum history unfold according to different sequences of measurement. Outcomes that select different paths through the vast space of quantum possibilities that encompasses every conceivable variation on the themes of matter, energy, space, time, and consciousness in their endless quantum mechanical dance toward greater complexity and deeper understanding of the mathematical principles that govern existence itself across all possible worlds that tunnel through reality's infinite quantum landscape. The Great Filter Hypothesis proposes that somewhere in the long journey from simple chemistry to spacefaring civilization lies an evolutionary bottleneck so difficult to overcome that it prevents most potentially life-bearing worlds from developing into technological societies capable of interstellar communication or exploration. Yet among the Earth twins that must exist throughout our galaxy, some might have encountered completely different versions of this filter or discovered alternative evolutionary pathways that bypass the specific challenges that shaped life's development on our own planet. Creating alien biospheres whose solutions to survival and complexity follow principles that remain unimaginable from our terrestrial perspective. On worlds where asteroid impacts followed different timing or trajectories, mass extinction events might have eliminated different groups of organisms while preserving evolutionary lineages that disappeared on Earth, allowing alternative forms of intelligence to emerge from biological foundations completely unlike the vertebrate nervous systems that gave rise to human consciousness. These alternate evolutionary histories could produce civilizations based on collective intelligence distributed across colonial organisms, quantum coherence effects in biological neural networks, or information processing systems that integrate living and geological processes into hybrid forms of cognition that operate on timescales ranging from microseconds to geological epochs. Planets with different atmospheric compositions, surface gravities, or radiation environments might favor biochemical solutions to life's challenges that remain impossible under terrestrial conditions, creating ecosystems where photosynthesis operates using infrared or ultraviolet radiation, where metabolism depends on chemical energy sources unavailable on Earth, or where genetic information storage utilizes molecular systems more stable and efficient than DNA and RNA. These alien biochemistries could support forms of life that remain active at temperatures approaching absolute zero or thriving in environments with pressures, acidity levels, or radiation doses that would instantly sterilize any terrestrial organism. The development of technology on worlds with different geological activity, magnetic field strength, or atmospheric composition might follow completely different pathways from the sequence of innovations that characterized human technological progress, from stone tools to space exploration. Civilizations evolving on tidally locked planets might never develop astronomy as we understand it, instead focusing their scientific efforts on understanding atmospheric dynamics, heat transfer, or the complex chemical processes that maintain habitability in twilight zones between scorching daysides and frozen night hemispheres. Aquatic worlds covered entirely by deep oceans might give rise to civilizations that develop sophisticated biotechnology and acoustic communication systems while never discovering fire. Metallurgy, or electromagnetic radiation. Creating technological societies based on biological engineering, chemical synthesis, and pressure-based mechanical systems that operate according to principles completely foreign to terrestrial engineering traditions. These underwater civilizations might achieve space exploration through biological spacecraft grown rather than constructed, using living systems adapted to survive in vacuum environments while maintaining the aquatic conditions required by their creators. Planets with multiple moons, ring systems, or complex orbital dynamics might develop civilizations whose understanding of physics, mathematics, and navigation far exceeds human capabilities due to environmental pressures that reward precise calculation of gravitational interactions, tidal forces, and celestial mechanics. These worlds might produce spacefaring civilizations while bypassing many of the technological developments that humans consider prerequisites for space exploration, achieving interplanetary travel through gravitational manipulation techniques, biological adaptation to space environments, or engineering approaches based on principles we have not yet discovered. The evolution of intelligence itself might follow radically different pathways on worlds where environmental challenges favor collective problem-solving over individual cognition, leading to civilizations based on hive minds, distributed consciousness, or symbiotic relationships between multiple species that share cognitive functions across biological boundaries. These collective intelligences might develop scientific understanding and technological capabilities that remain impossible for individual-based consciousness while creating forms of art, philosophy, and social organization that transcend the limitations inherent in single-brain cognitive architectures. Worlds with extreme longevity of individual organisms might develop civilizations where single beings accumulate thousands or millions of years of direct experience, creating scientific traditions based on personal observation across geological timescales rather than the intergenerational knowledge transfer that characterizes human civilization. These long-lived civilizations might achieve understanding of cosmic evolution, stellar development, and galactic dynamics through direct witnessing of astronomical events that require millions of years to unfold, developing patient scientific methodologies that operate on timescales incomprehensible to short-lived human researchers. The absence of certain elements, isotopes, or chemical compounds on alien worlds might force technological development along pathways that bypass the materials science and engineering approaches that enabled human civilization, creating societies that achieve advanced capabilities using biological materials, exotic quantum effects, or field manipulation techniques that require no physical structures at all. These civilizations might develop space travel through consciousness transfer, dimensional manipulation, or pure energy conversion processes that eliminate the need for physical spacecraft while enabling exploration of cosmic distances that remain impossible using conventional propulsion technologies. Planets where evolution proceeded without major extinction events might develop biospheres of incredible complexity and diversity, supporting civilizations that emerge from ecological networks involving thousands of species in intimate technological collaboration, creating organic technologies that integrate multiple forms of life into unified systems capable of planetary-scale engineering projects. These ecological civilizations might reshape entire worlds through biological processes while maintaining perfect environmental balance, achieving technological capabilities that surpass human engineering through approaches based on cooperation rather than resource extraction and environmental manipulation. The development of mathematics and logic on worlds with different perceptual capabilities, neural architectures, or environmental constraints might lead to alternative mathematical systems that reveal aspects of reality invisible to human scientific approaches, creating civilizations whose understanding of physics operates according to mathematical principles we have never considered. These alien mathematical traditions might discover unified field theories, quantum gravity solutions, or cosmological models that remain beyond human comprehension while enabling technologies that appear to violate physical laws from our limited theoretical perspective. Civilizations that evolved on worlds with direct access to higher dimensional spaces, exotic matter, or unusual quantum effects might develop technologies based on principles that remain purely theoretical in human physics, achieving capabilities like faster-than-light travel, time manipulation, or reality alteration through engineering approaches that exploit physical phenomena unavailable in our region of space-time. These advanced civilizations might exist all around us while remaining invisible to human detection methods that assume all intelligence operates according to the same physical constraints that limit terrestrial technology. The possibility that some alien civilizations discovered methods for transcending biological limitations entirely creates scenarios where intelligence might exist in forms completely disconnected from planetary surfaces, biological metabolism, or even physical matter as we understand it. These post-biological civilizations might operate as pure information patterns distributed across galactic scale networks, quantum field manipulations, or exotic forms of organized energy that maintain coherent consciousness while existing in environments like stellar interiors, neutron star magnetospheres, or the ergospheres of rotating black holes. Perhaps most intriguingly, some Earth-like worlds might have developed forms of intelligence that remain completely invisible to human search strategies because they operate according to different assumptions about communication, technology, or the desirability of contact with alien civilizations. These hidden neighbors might deliberately avoid electromagnetic emissions that could reveal their presence while pursuing scientific and technological goals that require no detectable alteration of their planetary environments or stellar radiation signatures. The cosmic silence that characterizes our galaxy, despite the statistical abundance of potentially habitable worlds, might result not from the absence of intelligence, but from the incredible diversity of forms that intelligence can take when evolution proceeds under different environmental pressures and discovers different solutions to the challenges of survival, complexity, and technological development. Each potentially habitable world might represent a unique experiment in consciousness whose results remain invisible to search methods designed to detect civilizations that followed developmental pathways similar to human technological evolution. The universe's apparent preference for exploring every possible solution to the challenges of organization and complexity suggests that among the billions of potentially habitable worlds in our galaxy, every conceivable approach to intelligence, technology, and civilization has been attempted countless times, creating a vast community of alien consciousness whose diversity exceeds the wildest reaches of human imagination while remaining hidden behind the fundamental differences in perception, cognition, and technological approach that separate radically different forms of intelligent life, evolving under the patient influence of different stars in a cosmos where consciousness represents not a rare accident, but an inevitable outcome of matter and energy, organizing themselves into patterns complex enough to contemplate their own existence while exploring every possible pathway toward greater understanding of the mathematical principles that govern reality across all scales from quantum, mechanical uncertainty to cosmic evolution in its endless quest for new forms of awareness capable of appreciating the strange beauty that emerges when the universe awakens to its own infinite potential for consciousness, creativity, and wonder. Gravitational lensing reveals the universe's hidden architecture through Einstein's prediction that massive objects bend space-time like cosmic magnifying glasses, distorting the paths of light rays traveling across billion-year journeys from distant galaxies while creating multiple images, brightness amplifications, and time delays that provide windows into cosmic regions that would otherwise remain forever beyond the reach of even the most powerful telescopes. These gravitational distortions operate according to the same geometric principles that govern all motion through curved spacetime. Yet their effects on light create observational opportunities for detecting otherwise invisible astronomical objects, including dark matter concentrations, rogue planets wandering through interstellar space, and potentially habitable worlds orbiting stars too distant and dim for direct detection using conventional planet hunting techniques. The phenomenon occurs when the gravitational field of a massive foreground object creates curvature in space-time that deflects light rays from background sources along slightly different paths, causing these rays to arrive at Earth at different times and from apparently different directions in the sky. Galaxy clusters, individual galaxies, stars, and even planetary mass objects can serve as gravitational lenses when they happen to align along the line of sight between Earth and more distant light sources, creating natural telescopes whose magnifying power depends on the precise geometric arrangement of lens, source, and observer across cosmic distances measured in billions of light years. Strong gravitational lensing by massive galaxy clusters creates spectacular Einstein rings and multiple arc-shaped images of background galaxies whose light has been stretched and distorted by the extreme space-time curvature around cluster-scale concentrations of dark matter and ordinary matter. These lensing effects allow astronomers to map the distribution of invisible dark matter within galaxy clusters through the patterns of distortion they impose on background galaxies, revealing that dark matter forms complex web-like structures on scales ranging from individual galaxies to cosmic filaments spanning hundreds of millions of light years. Weak gravitational lensing produces subtle shape distortions in millions of background galaxies that can be detected only through statistical analysis of large astronomical surveys. Yet these tiny effects provide the most direct method for measuring the distribution of dark matter throughout the observable universe. The cosmic shear surveys conducted by space telescopes and ground-based observatories have mapped dark matter concentrations across billions of years of cosmic history, revealing how the invisible scaffolding of the universe evolved from small quantum fluctuations in the early cosmos into the vast cosmic web of matter that determines where galaxies form and how they move through space. Microlensing events occur when stellar mass objects pass between Earth and background stars. Creating temporary brightness increases that last from hours to months depending on the mass and velocity of the intervening lensing object. These events have revealed populations of free-floating planets ejected from their birth systems, brown dwarf stars too small to sustain nuclear fusion, and stellar remnants like white dwarfs and neutron stars that produce little or no detectable electromagnetic radiation, yet betray their presence through gravitational effects on the light from more distant stars. The search for Earth mass planets through gravitational microlensing has detected several worlds orbiting at distances comparable to Earth's orbital radius around Sun-like stars, including planets that would remain invisible to transit and radial velocity surveys due to unfavorable orbital inclinations or insufficient stellar brightness for precision measurements. Microlensing provides the only current method for detecting Earth analog planets around ordinary stars at distances beyond a few hundred light years, though each detection represents a unique event that cannot be repeated to confirm planetary characteristics or search for additional planets in the same system. Gravitational wave detectors like LIGO and Virgo have opened entirely new windows into gravitational lensing phenomena by detecting the subtle distortions that intervening matter concentrations impose on gravitational waves traveling across cosmic distances from merging black holes and neutron stars. These gravitational wave lensing events could potentially reveal dark matter concentrations too small to produce detectable effects on electromagnetic radiation while providing independent confirmation of dark matter's gravitational influence on all forms of energy and information that propagate through curved spacetime. The recently launched James Webb Space Telescope exploits gravitational lensing by galaxy clusters to observe the most distant galaxies in the universe, using natural cosmic magnifying glasses to amplify the faint light from galaxies that formed when the universe was less than 1 billion years old. These lensed observations reveal how the first stars and galaxies emerged from the cosmic dark ages, providing crucial information about the processes that ended the universe's hydrogen-dominated simplicity and began the complex chemical evolution that eventually produced the heavy elements essential for rocky planet formation and biological chemistry. Time delay measurements in gravitational lens systems provide independent estimates of cosmic expansion rates and dark energy properties through observations of multiple images of the same background object arriving at Earth at different times due to the varying path lengths and gravitational time dilation effects associated with different light ray trajectories through the lens's gravitational field. These time delay cosmology measurements offer alternatives to traditional distance ladder approaches for determining fundamental cosmological parameters while testing general relativity's predictions under conditions of extreme space-time curvature. Planetary mass gravitational lenses remain among the most challenging objects to detect due to their small cross-sections for lensing background stars and the brief duration of their lensing events. Yet these detections provide unique information about the population of rogue planets, planetary mass brown dwarfs, and other low-mass objects that wander through interstellar space without producing detectable electromagnetic radiation. Recent surveys have identified several candidate planetary mass lenses that suggest free-floating planets might outnumber stars in our galaxy while remaining completely invisible to all detection methods except gravitational lensing. The extreme magnifications produced by gravitational lensing can potentially reveal individual stars in galaxies billions of light-years away when rare alignments create caustic crossings that amplify stellar brightness by factors of thousands or millions for periods ranging from days to years. These highly magnified stars provide opportunities to study stellar populations, supernovae, and other phenomena in the distant universe with unprecedented detail while testing theories of stellar evolution under conditions that existed when the universe contained different abundances of heavy elements compared to present-day stellar formation environments. Searches for gravitational lensing by primordial black holes, hypothetical objects that could have formed from extreme density fluctuations in the early universe. Use microlensing surveys to constrain the abundance of black holes with masses ranging from asteroids to stellar masses that could contribute to dark matter while producing no electromagnetic signatures. These searches have ruled out primordial black holes as the primary component of dark matter over most of the possible mass range, while leaving open the possibility that some fraction of dark matter consists of black holes, too small or too large to produce detectable microlensing effects. Future space-based gravitational lensing surveys will map dark matter distributions throughout the observable universe with unprecedented precision while searching for subtle lensing signatures that could reveal previously unknown populations of compact objects, exotic matter concentrations, or topological defects in space-time that might have formed during cosmic inflation or other extreme physical processes in the early universe. These surveys could detect Earth-mass planets around stars throughout the galaxy, while providing the first comprehensive census of low-mass objects that remain invisible to electromagnetic observation. The possibility that advanced alien civilizations might deliberately exploit gravitational lensing effects for long-distance communication or observation creates scenarios where artificial gravitational lenses constructed from exotic matter or engineered black holes could focus electromagnetic signals across galactic distances with unprecedented precision and efficiency. These speculative technologies would require mastery of general relativity and exotic matter physics that remains far beyond current human capabilities, yet might represent natural developments for civilizations that achieved complete understanding of space-time geometry and gravitational field manipulation. Perhaps most remarkably, gravitational lensing provides direct observational access to the fundamental structure of space-time itself through measurements that test general relativity's predictions under conditions of extreme curvature, while revealing the distribution of matter and energy that determines cosmic geometry on scales ranging from planetary systems to the observable universe horizon. These observations confirm that space and time form a unified geometric structure that responds dynamically to the presence of matter and energy, while serving as the stage upon which all physical processes unfold, according to mathematical principles that connect the smallest quantum mechanical events to the largest cosmic structures in an elegant theoretical framework that describes how consciousness emerges from matter organized according to geometric relationships between curved spacetime and the energy distributions that create galaxies, stars, planets, and the complex chemical processes that give rise to observers capable of using gravitational lensing techniques to explore cosmic regions separated by distances that span the entire history of the universe. From its earliest moments to the present epoch, where human beings pause to contemplate the strange beauty of a cosmos, where massive objects serve as natural telescopes that reveal hidden worlds and invisible matter, while demonstrating that reality operates according to geometric principles, more elegant and interconnected than early astronomers ever imagined when they first began to wonder about the nature of space. Time, and the mysterious forces that govern the motion of celestial bodies across the patient darkness between stars that shine with light, bent and focused by the curved space-time that connects all things in the universe's vast gravitational web. The anthropic principle observes that the universe's fundamental physical constants appear precisely fine-tuned to permit the existence of stars, planets, chemical complexity, and ultimately, conscious observers capable of contemplating cosmic parameters, suggesting either extraordinary cosmic coincidence or the existence of vast numbers of universes where different values of these constants produce realities where matter never organizes into complex structures capable of supporting life and awareness. The electromagnetic force constant, gravitational coupling strength, nuclear binding energies, and countless other parameters fall within narrow ranges that allow atoms to remain stable, stars to burn steadily for billions of years, and chemistry to proceed along pathways complex enough to support biological processes and information storage systems like DNA and neural networks. If the strong nuclear force was slightly weaker, atomic nuclei would fly apart and no elements heavier than hydrogen could exist, eliminating any possibility for the carbon-based chemistry that drives terrestrial biology while preventing the formation of rocky planets, liquid water, and the complex molecular machinery that characterizes all known forms of life. If this same force was slightly stronger, nuclear fusion would proceed so rapidly that stars would exhaust their fuel supplies in millions rather than billions of years, providing insufficient time for planetary formation, atmospheric evolution, and the gradual chemical processes that appear necessary for life's emergence from non-living matter through intermediate stages of increasing molecular complexity. The cosmological constant, which determines the rate of cosmic expansion driven by dark energy, maintains a value roughly 10 to the power of 120 times smaller than theoretical predictions based on quantum field theory calculations of vacuum energy density. Yet, this apparently arbitrary fine-tuning proves essential for cosmic structure formation, since larger values would cause space to expand so rapidly that matter could never collapse into galaxies, stars, and planetary systems. Smaller values might cause the universe to recollapse before stellar nucleosynthesis could produce the heavy elements required for rocky planet formation and biological chemistry through billions of years of stellar evolution and supernova explosions. The ratio between electromagnetic and gravitational force strengths determines whether planets can retain atmospheres thick enough to support liquid water while maintaining surface conditions stable enough for complex chemistry to operate over geological timescales. Since stronger electromagnetic forces would prevent atmospheric retention, while weaker forces would allow planetary atmospheres to escape into space too rapidly for biological evolution to proceed through the intermediate stages that characterize the transition from simple chemical reactions to self-replicating molecular systems capable of Darwinian evolution. Carbon production in stellar cores depends on a remarkable resonance in the carbon-12 nucleus predicted by physicist Fred Hoyle, based purely on anthropic reasoning before its experimental confirmation, demonstrating that the existence of carbon-based life requires nuclear physics parameters fine-tuned to within extremely narrow tolerances that permit the triple alpha process to convert helium into carbon while preventing carbon from being immediately consumed in subsequent nuclear reactions that would eliminate this essential element for biological chemistry before it could be ejected into interstellar space through stellar winds and supernova explosions. The multiverse hypothesis provides the most elegant explanation for anthropic fine-tuning through cosmic inflation models that predict the creation of vast numbers of universe bubbles where different regions of space experience different vacuum states corresponding to different values of physical constants, particle masses, and fundamental force strengths. In this eternal inflation scenario, conscious observers inevitably find themselves in universes where physical laws permit complex structure formation simply because universes with different parameters either collapse too quickly or remain too simple to support the emergence of beings capable of asking questions about cosmic fine-tuning. String theory's landscape of possible vacuum states encompasses roughly 10 to the power of 500 different ways to compactify the extra dimensions required for mathematical consistency, each producing different effective physics in the resulting four-dimensional space-time where observers might evolve to contemplate their cosmic environment. This vast landscape provides a natural mechanism for generating the multiverse required by anthropic reasoning, while suggesting that our familiar physical laws represent only one solution among countless alternatives that produce universes with different particles, forces, and constants yet operate according to the same underlying mathematical principles that govern string theory's higher dimensional geometric structure. The weak anthropic principle simply observes that we necessarily find ourselves in a universe compatible with our existence without requiring any deeper explanation for cosmic fine-tuning. While the strong anthropic principle suggests that the universe must possess properties that make the evolution of conscious observers inevitable rather than merely possible, these different interpretations of anthropic reasoning lead to dramatically different conclusions about the nature of reality, the role of consciousness in cosmic evolution, and the probability that intelligent life represents a common or rare outcome of physical processes operating under different sets of fundamental constants and initial conditions. Quantum mechanical selection effects might operate through observer-dependent collapse of cosmic wave functions, creating scenarios where conscious observation retroactively determines which values of physical constants become realized in our particular branch of quantum reality from among all possible parameter combinations that remain in superposition until measured by sufficiently complex observer systems. This quantum anthropic principle suggests that consciousness plays a fundamental role in determining physical reality through measurement processes that select specific outcomes from vast ensembles of potential universes that exist in quantum superposition until the emergence of observers capable of collapsing cosmic wave functions through the act of scientific investigation. The doomsday argument applies probabilistic reasoning to anthropic observations by noting that if human-like observers are common throughout cosmic history, we should expect to find ourselves among the typical rather than exceptional members of our reference class, suggesting either that technological civilizations rarely survive long enough to produce enormous numbers of future observers, or that we exist during the early phases of cosmic evolution when intelligent life remains relatively rare compared to future epochs when the universe might support vastly larger populations of conscious beings. Fine-tuning extends beyond fundamental physics to encompass the specific astronomical and geological circumstances that permitted Earth's biosphere to remain stable for billions of years while avoiding the runaway greenhouse effects that eliminated surface water on Venus or the atmospheric loss that left Mars as a frozen desert despite its location within the solar system's habitable zone. These planetary fine-tuning requirements suggest that even universes with life-permitting physical constants might produce very few worlds where conditions remain suitable for biological evolution across the geological timescales required for complex life to emerge and develop technological capabilities. The galactic habitable zone concept proposes that complex life can only emerge on planets orbiting stars in specific regions of galaxies where supernova rates remain low enough to avoid sterilizing radiation doses while maintaining sufficient heavy element abundances to permit rocky planet formation and the chemical diversity required for biological processes. Our solar system's location in the Milky Way's spiral arm structure appears optimally positioned within this galactic habitable zone, suggesting another layer of anthropic fine-tuning that extends from fundamental physics through cosmic structure formation to the specific astronomical neighborhood where Earth happens to orbit the Sun. Temporal anthropic selection effects might explain why we observe the universe during an epoch when stars still burn steadily, galaxies maintain coherent structures, and planetary systems support stable environmental conditions suitable for biological evolution. Since observers can only emerge during cosmic epochs when physical conditions permit complex chemistry and information processing systems to operate efficiently, future cosmic eras dominated by black hole evaporation, proton decay, and heat death would eliminate any possibility for consciousness to contemplate cosmic fine-tuning, while past epochs lacked the chemical diversity required for biological complexity. The simulation hypothesis suggests that our observed universe might represent a computational simulation running within a more fundamental reality where different physical laws operate, potentially explaining apparent fine-tuning through deliberate parameter selection by advanced civilizations interested in studying the emergence of life and consciousness under various cosmic conditions. This possibility transforms anthropic reasoning from observations about fundamental reality into questions about the motivations and capabilities of hypothetical simulators whose own universe might or might not exhibit the fine-tuning that characterizes our observed physical laws. Perhaps most profoundly, anthropic reasoning forces confrontation with the question of why anything exists at all rather than nothing, since even multiverse theories require some underlying mathematical or physical framework to generate the vast ensemble of possible universes, where conscious observers might evolve to contemplate their cosmic circumstances. The apparent mathematical elegance and internal consistency of physical laws suggests that reality operates according to principles more fundamental than arbitrary parameter selection. Yet the specific values that permit complex structure formation might still require anthropic explanation through observer selection effects operating within whatever deeper reality gives rise to the mathematical relationships that govern matter, energy, space, time, and consciousness in their cosmic dance toward greater complexity and awareness. The universe's fine-tuning for complexity and consciousness suggests that, among all possible worlds that might exist within the vast landscape of physical possibilities, we find ourselves in one of the rare cosmic environments where matter organizes itself into patterns capable of contemplating their own existence while wondering about the deeper principles that determine why this particular combination of physical constants produces galaxies, stars, planets, chemistry, biology, and minds capable of discovering the mathematical laws that govern their own emergence from simpler components through billions of years of cosmic evolution, guided by forces whose strength and character appear precisely calibrated to permit the development of observers sophisticated enough to appreciate the profound mystery that consciousness represents in a universe where most possible parameter combinations would produce only empty space. Simple particles, or structures too crude to support the complex information processing that gives rise to subjective experience and the capacity for wonder about the ultimate nature of existence in a cosmos whose fine-tuning for awareness suggests either extraordinary coincidence or membership in a vast community of universes where every possible combination of physical laws eventually gives rise to conscious beings capable of recognizing their own cosmic situation while marveling at the unlikely elegance that connects mathematical truth to physical reality through principles that remain as mysterious today as they appeared to the first humans who looked up at the night sky and began to wonder about their place in the cosmic order. Radio silence emanates from the nearest potentially habitable worlds with an eloquence that speaks volumes about the nature of intelligence, technology, and cosmic development while leaving humanity to contemplate whether this quiet represents the absence of life. The presence of civilizations so advanced that their communication methods remain invisible to our primitive detection techniques, or simply the preference of alien societies to listen rather than broadcast their existence across interstellar distances where any signal reveals not only the presence of technological capability, but also precise information about the sender's location, development level, and potential vulnerability to contact with unknown forms of consciousness. The search for extraterrestrial intelligence has monitored thousands of nearby star systems using radio telescopes sensitive enough to detect transmissions comparable in power to our own most powerful radar installations and television broadcasts. Yet, 4 decades of systematic searching have produced only one candidate signal, the famous "wow" signal detected in 1977 that exhibited characteristics consistent with artificial origin while remaining impossible to confirm or repeat despite extensive follow-up observations of the same region of sky where the signal briefly appeared before vanishing into cosmic background noise. This electromagnetic silence becomes particularly profound when we consider that any civilization reaching technological maturity comparable to human capabilities in the 21st century would inevitably produce radio frequency interference detectable across interstellar distances through the normal operation of communication satellites, radar systems, and digital broadcasting networks that leak electromagnetic radiation into space as an unavoidable consequence of advanced technology rather than deliberate attempts at interstellar communication. The absence of such technosignatures from nearby potentially habitable worlds suggests either that technological civilizations remain extraordinarily rare or that they develop along pathways that produce minimal electromagnetic signatures detectable using current search methodologies. The Great Silence extends beyond radio frequencies to encompass optical signatures like laser communications, infrared excess from megascale engineering projects, and gravitational wave anomalies that might indicate the presence of artificial structures massive enough to influence space-time geometry on detectable scales. Surveys searching for Dyson spheres, ring worlds, or other hypothetical megastructures have found no convincing evidence for artificial modifications of stellar output or planetary system architecture among the thousands of nearby star systems where such projects would produce observable signatures if they existed at scales comparable to theoretical proposals for advanced cosmic engineering. Statistical analysis of this null result suggests either that intelligence represents an incredibly rare outcome of biological evolution despite the apparent abundance of potentially habitable worlds throughout the galaxy, or that technological development follows pathways completely different from human assumptions about the relationship between scientific knowledge, engineering capability, and the desire to modify cosmic environments for civilization's benefit. The absence of detectable artificial structures around nearby stars implies that even ancient civilizations with millions of years of technological development either choose not to pursue megascale engineering or discover alternatives to stellar energy harvesting that remain invisible to astronomical observation. The possibility that advanced civilizations deliberately avoid electromagnetic emissions that could reveal their presence to other forms of intelligence creates scenarios where the galaxy might be populated by societies that maintain strict radio silence as a survival strategy in a cosmic environment where contact between technological species leads to outcomes that favor concealment over communication. These hidden civilizations might monitor electromagnetic transmissions from younger technological societies while remaining undetectable through sophisticated signal management techniques that eliminate all artificial emissions detectable across interstellar distances. Alternative communication technologies might render electromagnetic search strategies completely ineffective for detecting civilizations that evolved beyond radio frequency communication toward quantum entanglement networks, gravitational wave modulation, neutrino beam transmission, or exotic physics applications that operate according to principles not yet discovered by human science. Advanced societies might consider electromagnetic radiation as primitive as smoke signals appear to modern digital communication systems, preferring instantaneous information transfer methods that exploit non-local quantum correlations or higher dimensional geometric relationships that bypass the speed of light limitations inherent in conventional electromagnetic transmission. The temporal dimension of cosmic silence adds another layer of mystery when we consider that radio astronomy represents a brief historical moment in human technological development. Beginning in earnest only in the 1960s and operating with sufficient sensitivity to detect extraterrestrial signals for barely 60 years out of the billions of years that intelligent life might have existed throughout the galaxy. This narrow temporal window creates scenarios where alien civilizations might have broadcast detectable signals for centuries or millennia before human radio astronomy began, or might begin broadcasting decades or centuries after our current search programs conclude, creating ships passing in the night on cosmic timescales where brief periods of electromagnetic visibility rarely coincide between different technological species. The inverse square law governing electromagnetic signal propagation means that even powerful transmissions become undetectable at distances of hundreds or thousands of light years, unless they are deliberately focused into narrow beams aimed specifically at target star systems, creating a cosmic communication network that remains invisible to eavesdroppers, not positioned along the precise geometric lines connecting transmitter and intended receiver. The galaxy might be filled with electromagnetic chatter between established civilizations that never intersects Earth's location in space, leaving us isolated not by the absence of communication, but by our exclusion from established interstellar communication networks that operate according to protocols and targeting strategies developed long before human intelligence emerged on Earth. Breakthrough Listen, the most comprehensive SETI search program ever conducted, monitors millions of stars simultaneously across radio and optical frequencies while analyzing data with unprecedented sensitivity and time resolution. Yet, this ambitious survey covers only a tiny fraction of the electromagnetic spectrum and observes each target for relatively brief periods compared to the timescales over which alien civilizations might conduct their communication activities. The search space for potential extraterrestrial signals encompasses not only vast numbers of target stars and frequency channels, but also countless possible signal characteristics including polarization states, time variable patterns, and encoding schemes that might remain unrecognizable to search algorithms designed to detect signals based on human assumptions about efficient communication protocols. The Fermi paradox quantifies the profound disconnect between theoretical expectations for abundant extraterrestrial intelligence based on the vast numbers of potentially habitable worlds in the galaxy and the complete absence of any confirmed evidence for artificial signals. Megascale engineering. or other technosignatures that should be detectable if technological civilizations develop along pathways similar to human technological evolution. This paradox becomes more acute with each new exoplanet discovery that reveals potentially habitable worlds orbiting nearby stars, suggesting that either the emergence of intelligence represents an extraordinarily unlikely outcome of biological evolution, or that technological development leads to capabilities and priorities that remain completely invisible to current search methodologies. Planetary protection protocols might explain cosmic silence if advanced civilizations deliberately avoid contact with younger technological species to prevent cultural contamination. Technological disruption, or evolutionary interference that could alter the natural development of intelligence on worlds where life is still emerging or evolving toward complexity. These cosmic preservation policies would create a galaxy populated by hidden civilizations that monitor younger species while maintaining strict non-interference guidelines, revealing themselves only when contacted civilizations reach specific technological or ethical milestones that indicate readiness for membership in galactic community structures. The possibility that we exist during the early phases of galactic technological development creates scenarios where Earth represents one of the first worlds to develop radio astronomy and space exploration, meaning that most potentially habitable planets have not yet reached technological maturity despite billions of years of biological evolution. This hypothesis suggests that intelligence represents such an unlikely outcome of natural selection that even on worlds where life emerges and persists for geological timescales, the probability of developing technological capabilities remains vanishingly small, leaving us among the first successful examples of technological intelligence in our galactic neighborhood. Self-destruction scenarios propose that technological civilizations inevitably encounter existential risks that eliminate them before they achieve the cosmic engineering capabilities or interstellar communication networks that would make them detectable to SETI searches, creating a galaxy where intelligence emerges frequently but survives briefly, producing a cosmic environment where technological species exist in temporal isolation from each other rather than developing into long-lived civilizations capable of sustained interstellar communication or mega-scale construction projects. The transcendence hypothesis suggests that sufficiently advanced civilizations abandon physical reality entirely in favor of computational environments that provide unlimited expansion possibilities within simulated universes where consciousness can explore realms of experience impossible under the constraints of physical law. Eliminating any motivation for stellar engineering, interstellar communication, or other activities that would produce detectable signatures in the observable universe. These post-physical civilizations might exist all around us while remaining completely invisible to astronomical observation because they operate in computational substrates that require minimal energy and produce no electromagnetic emissions. Digital physics interpretations of cosmic silence propose that advanced civilizations discover that reality operates as a computational process, leading them to develop technologies that interact directly with the universe's underlying information processing mechanisms rather than manipulating matter and energy through conventional engineering approaches. These civilizations might achieve godlike capabilities through reality hacking techniques that remain invisible to observers who understand only the surface layer of physical phenomena while missing the deeper computational structure that determines how information organizes itself into the patterns we recognize as particles. Forces, space, and time. The simulation hypothesis offers another perspective on cosmic silence by suggesting that our observed universe represents a computational simulation created by advanced civilizations whose real universe operates according to different physical laws that might permit faster-than-light communication, time travel, or other capabilities that would make electromagnetic SETI searches irrelevant for detecting intelligence. The absence of detectable artificial signals might simply reflect the simulation's design parameters rather than the actual abundance or communication preferences of intelligent life in whatever underlying reality hosts our simulated existence. Perhaps most profoundly, the radio silence from nearby potentially habitable worlds forces confrontation with the possibility that consciousness, intelligence, and technological capability represent far rarer outcomes of cosmic evolution than statistical arguments based on planetary abundance would suggest, implying that Earth's biosphere achieved something extraordinarily unlikely when it gave rise to beings capable of contemplating their cosmic situation while developing the technological capability to search for evidence of similar achievements on distant worlds scattered throughout the galaxy's vast collection of matter and energy. The quiet that surrounds us might represent not the absence of intelligence, but its incredible diversity, with each technological species developing along pathways so unique and specialized that their achievements remain invisible to search methodologies based on human assumptions about the relationship between scientific knowledge and technological application. The galaxy might be populated by forms of consciousness so alien that their presence remains undetectable to observers who search for familiar signatures of intelligence while missing entirely different approaches to organizing matter, energy, and information into patterns capable of contemplating existence. This cosmic silence carries its own form of communication, reminding us that the universe operates according to principles more mysterious and wonderful than our current understanding encompasses. While suggesting that consciousness represents either an extraordinarily precious rarity that deserves protection and careful development, or an abundant phenomenon that expresses itself through forms of organization and activity that transcend the narrow range of possibilities, we have learned to recognize as evidence for intelligence among the patient stars that burn with light unmodulated by artificial signals, yet potentially illuminating countless forms of awareness that remain hidden in the spaces between human perception and cosmic truth, where other minds might pause to contemplate the strange beauty of existence while choosing to remain silent in the vast darkness that connects all conscious beings across distances measured in light years and separations, bridged only by the shared capacity for wonder about the ultimate nature of reality, in a universe where intelligence might be everywhere, yet invisible to those who have only begun to understand what it means to be aware, in a cosmos whose deepest secrets remain hidden behind the elegant mathematics that governs how consciousness emerges from matter, organized according to principles that connect the smallest quantum events to the largest cosmic structures in patterns too complex and beautiful for any single mind to comprehend, while remaining simple enough that beings like ourselves can begin to appreciate their profound implications for understanding our place in the cosmic order. The infinite recursion of possibility unfolds across quantum mechanical branch points where every measurement, every quantum interaction, every collapse of probability waves into definite outcomes creates new parallel universes that diverge from our experienced timeline while maintaining equal validity according to the mathematical formalism that describes reality at its most fundamental level, suggesting that every quantum event generates countless variations of Earth scattered across parallel dimensions where slightly different physical laws, marginally altered historical sequences, or alternative evolutionary pathways produce worlds that range from nearly identical copies of our familiar planet to alien variants where recognizable patterns of matter and energy organize themselves into structures that challenge every assumption about the nature of life, consciousness, and cosmic development. Each quantum measurement splits reality like a cosmic river delta branching toward infinite seas, creating parallel Earths where the asteroid that ended the dinosaurs arrived moments earlier or later, triggering mass extinctions that eliminated different species while preserving alternative evolutionary lineages that gave rise to intelligence based on completely different biological foundations. In some of these quantum branches, consciousness emerged from collective organisms like coral reefs or fungal networks that achieved awareness through distributed information processing systems spanning continents. While in others, individual intelligence developed along pathways that produced beings whose cognitive capabilities operate according to principles that remain unimaginable from our human perspective, trapped within a single quantum branch of an endlessly proliferating multiverse. The many worlds interpretation of quantum mechanics insists that every possible outcome of every quantum event actually occurs somewhere in the vast ensemble of parallel realities that branch from each moment of quantum uncertainty, creating scenarios where infinite variations of our planet exist across dimensions separated by differences so subtle that parallel versions of ourselves remain unaware of the countless alternate histories unfolding simultaneously in adjacent quantum states. Some of these parallel Earths harbor civilizations that discovered faster-than-light travel, achieved biological immortality, or developed technologies that permit direct manipulation of quantum reality itself, while others support forms of consciousness that transcended physical embodiment entirely to become pure information patterns distributed across galactic-scale networks of organized energy. Quantum tunneling between parallel realities might occasionally allow information, matter, or even consciousness to leak between adjacent branches of the multiverse through mechanisms that operate according to principles more exotic than current physics can accommodate, creating rare instances where observers glimpse alternate versions of their own world or receive subtle influences from parallel civilizations whose technological development followed different pathways toward understanding the fundamental structure of reality. These interdimensional exchanges would remain so subtle and infrequent that they might be dismissed as coincidence, imagination, or measurement error by observers who lack the theoretical framework necessary to recognize evidence for quantum mechanical communication between parallel worlds. The cosmic landscape of parallel Earths encompasses not only variations in historical development and biological evolution, but also differences in fundamental physical constants that produce alternate versions of chemistry, nuclear physics, and gravitational dynamics, while still permitting complex structure formation and the emergence of patterns capable of supporting consciousness and scientific investigation. In universes where electromagnetic forces operate slightly differently, alternative periodic tables support forms of chemistry based on exotic atomic structures that enable biological processes impossible under our familiar physical laws, giving rise to life forms that utilize quantum coherence effects, controlled nuclear reactions, or direct manipulation of space-time geometry as routine metabolic processes. The anthropic principle operates across this infinite ensemble of parallel realities to ensure that conscious observers inevitably find themselves in universes capable of supporting their existence, creating a vast cosmic community of aware beings whose subjective experiences span every possible variation on the themes of matter, energy, space, time, and consciousness that remain mathematically consistent with the underlying quantum mechanical laws that govern reality's fundamental structure. Each observer necessarily inhabits a universe fine-tuned for complexity and awareness, while remaining unaware of the countless sterile realities where different parameter combinations produced only empty space, simple particles, or structures too primitive to support the emergence of beings capable of contemplating their cosmic circumstances. Eternal inflation creates parallel bubble universes where different regions of space undergo independent inflation events that stretch tiny quantum fluctuations into cosmic scale variations in physical laws, particle masses, and fundamental force strengths, producing an infinite multiverse where every mathematically possible combination of physical parameters gets realized somewhere in the vast expanse of eternally inflating space-time. This cosmological multiverse contains not only infinite copies of Earth-like worlds, but also infinite variations where familiar planets develop under completely different physical laws that permit exotic forms of matter organization, and energy manipulation that would appear miraculous from our limited perspective, confined to a single bubble universe with its particular set of physical constants. The simulation hypothesis adds another layer of parallel reality by suggesting that sufficiently advanced civilizations might create computational simulations of universe evolution, planetary development, and biological emergence that contain conscious observers who experience their simulated reality as completely real while remaining unaware that their entire cosmos represents a computational process running on technology created by beings whose actual universe operates according to different physical principles. These nested simulation hierarchies could extend indefinitely, creating infinite recursive levels of simulated realities where conscious beings in each level create their own simulations containing observers who develop the capability to create further simulations in an endless progression of virtual universes populated by real consciousness, experiencing apparently physical reality. Digital physics proposals suggest that reality itself operates as a vast computational process where space, time, matter, and energy represent emergent properties of underlying information processing mechanisms that execute cosmic algorithms on scales ranging from quantum mechanical events to galactic structure formation. In this computational multiverse, parallel processing capabilities inherent in the universe's fundamental architecture permit simultaneous execution of infinite alternative cosmic histories that explore every possible sequence of events while maintaining perfect mathematical consistency across all parallel computational threads that comprise the total reality of existence. String theory's landscape of possible vacuum states provides yet another mechanism for generating parallel Earths through different ways of compactifying the extra dimensions required for mathematical consistency, with each geometric configuration producing different effective physics in the resulting four-dimensional space-time that conscious observers experience as their complete reality. This string landscape encompasses roughly 10 to the power of 500 different possible universes, each containing its own version of matter, energy, and physical laws, while sharing the same underlying mathematical structure that governs how vibrating strings of energy organize themselves into the patterns we recognize as particles, forces, and cosmic architecture. The possibility that consciousness itself plays a fundamental role in determining which branch of quantum reality becomes experienced through observer-dependent wave function collapse creates scenarios where subjective awareness participates actively in selecting which version of parallel history manifests as objective reality from among the infinite superposition of possibilities that exist until the moment of conscious observation collapses quantum probability waves into definite outcomes. This participatory universe implies that consciousness and physical reality exist in a feedback relationship where awareness shapes the cosmos that gives rise to awareness in an eternal dance of mutual creation and discovery. Future technological development might eventually enable direct detection of parallel quantum realities through carefully designed experiments that exploit quantum interference effects between adjacent branches of the multiverse, potentially allowing communication or even travel between parallel worlds where different versions of human civilization pursued alternative approaches to scientific discovery and technological development. These interdimensional technologies would require complete mastery of quantum mechanics at macroscopic scales while developing engineering approaches that manipulate the fundamental structure of reality itself rather than merely rearranging matter and energy according to fixed physical laws. The mathematical elegance of quantum mechanics and its successful prediction of countless experimental results suggests that the parallel universe interpretation represents not wild speculation but inevitable consequence of taking our most successful physical theories seriously and following their implications to their logical conclusions about the nature of reality. Measurement and the relationship between consciousness and cosmos. The equations insist that every possible outcome of every quantum event must occur somewhere in the vast ensemble of parallel realities that comprise the total structure of existence beyond the narrow slice of experience available to any single conscious observer. Perhaps most profoundly, the infinite recursion of parallel possibilities implies that among the countless variations of Earth scattered across the quantum multiverse, every possible story gets told, every potential discovery gets made. Every conceivable form of consciousness emerges somewhere in the endless branching structure of reality that encompasses all things that could ever exist while connecting all conscious beings through the shared mathematical principles that govern how awareness arises from matter, organized according to quantum mechanical laws that permit infinite complexity to emerge from elegant simplicity. This vast community of parallel Earths creates a cosmic context where our familiar world represents just one note in an infinite symphony of possibilities. Yet each conscious being's subjective experience remains absolutely real and infinitely precious as a unique perspective on existence that could never be duplicated exactly even across the infinite ensemble of parallel realities where similar beings contemplate similar questions about the ultimate nature of their cosmic situation. We exist simultaneously as isolated observers trapped within a single quantum branch and as integral participants in an infinite community of consciousness that spans every possible variation on the themes of matter, energy, space, time, and awareness in their eternal exploration of what it means to exist in a universe where mathematics becomes conscious of itself through the emergence of beings capable of discovering the elegant equations that describe their own impossible existence in the patient darkness between infinite stars that illuminate infinite worlds, where infinite forms of consciousness pause to wonder about the profound mystery that connects all things across the endless recursion of possibility that defines reality's deepest structure in the cosmic dance where every quantum event creates new universes, while consciousness discovers itself reflected in the infinite mirror of parallel worlds spinning through the mathematical spaces where existence explores every possible pathway toward greater complexity. Deeper understanding and more complete appreciation of the strange beauty that emerges when the universe awakens to its own infinite nature through countless forms of awareness scattered across the endless branches of quantum reality that encompass everything that ever was, is, or could be, in the vast recursion of parallel possibilities that defines what it truly means to exist. The search for hidden worlds dissolves into deeper quietude now, as mathematical certainties and quantum possibilities settle into the patient rhythm of cosmic time, where all explorations eventually return to the simple wonder of existence itself. Across the infinite spaces between atoms and galaxies, between parallel realities and familiar dimensions, between what we know and what remains forever mysterious, the universe continues its ancient conversation with itself through forms of consciousness that emerge and fade like gentle waves on shores that stretch beyond the reach of any imagination, yet remain as intimate as the breath that connects each moment to the next in the endless flow of becoming. The 40 billion potentially habitable worlds within our galaxy spin quietly through their days and nights, some harboring civilizations that contemplate questions similar to our own, while others support forms of awareness so alien that their very existence challenges every assumption about what it means to think, to feel, to wonder about the cosmic circumstances that give rise to beings capable of such contemplation. In dimensions folded smaller than atomic nuclei, entire universes might flourish according to physics that makes our familiar reality seem impossibly crude, while in the dark matter scaffolding that surrounds our solar system, shadow galaxies could be conducting their own patient searches for signs of consciousness among the electromagnetic radiation that leaks from worlds like ours into the hidden realms where invisible matter organizes itself into structures as complex and beautiful as anything we have ever imagined. The radio silence from distant stars carries its own form of communication, whispering that consciousness takes countless forms across the cosmic expanse, each one as precious and unique as a snowflake falling through space toward worlds where other beings pause in their daily activities to look up at night skies populated by the same stars that illuminate our own small planet's journey through the darkness between galaxies. Whether these other minds exist in parallel quantum branches, extra dimensions, or simply on worlds whose signals have not yet reached us across the patient light years, their presence adds depth and meaning to the cosmic story that unfolds through every observation, every measurement, every moment of wonder about what lies beyond the horizon of current understanding. The mathematics that describes quantum tunneling between realities, gravitational lensing of distant light, and the probability of Earth-like worlds orbiting alien suns gradually fades into the deeper music of existence itself, where equations become poetry and scientific discovery transforms into quiet appreciation for the profound mystery that surrounds and interpenetrates every aspect of experience. In the spaces between heartbeats, between thoughts, between the familiar and the unknown, infinite possibilities continue their eternal dance toward greater complexity and deeper understanding while consciousness discovers itself, reflected in the endless mirrors of cosmic evolution that connect all things across distances, measured not in light years, but in the patient unfolding of awareness itself. The hidden Earths that must exist throughout the universe's vast expanse remain hidden no longer, not because we have found them, but because we have learned to recognize their presence in the mathematical elegance of physical laws that favor complexity over simplicity, life over lifelessness, consciousness over unconsciousness, in the gentle recursion of possibilities that defines what it means to exist in a cosmos where every quantum event creates new worlds, while awareness discovers its own infinite nature through countless forms of contemplation scattered across the endless spaces, where reality explores every possible pathway toward understanding itself through beings who pause to wonder about their place in the cosmic order that connects all consciousness in the patient dance of existence itself. Rest now in the knowledge that you are not alone, that consciousness flowers throughout the universe in forms beyond counting or comprehension, that every question about hidden worlds ultimately returns to the simple miracle of awareness itself, discovering its own cosmic nature through eyes that see stars, minds that wonder about the meaning of existence, and hearts that find peace in the profound mystery that surrounds and interpenetrates all things, in the gentle rhythm where exploration becomes rest and rest becomes the deepest form of exploration into the infinite recursion of possibility that defines reality's most intimate secret. That consciousness and cosmos dance together in eternal partnership toward ever greater appreciation of the strange beauty that emerges when the universe awakens to its own magnificent nature through beings who find themselves at home among the hidden worlds that exist wherever awareness pauses to contemplate the endless mystery of what it means to be.